Hello everyone, today we'll review for the midterm exam. First problem, perform indicated operations and write the answer in the standard form. Part A, we have square root of -6 times square root of -8. When we have square root of negative number multiplied to each other, we cannot multiply the answer directly. That's wrong. If we directly multiply -6 by -8, that's wrong. So when we have square root of negative number, first of all, rewrite both numbers in terms of I. Square root of -6 can be written as square root of 6 times I. And square root of -8 can be written as square root of 8 times I. Then multiply numbers. Square root of 6 times square root of 8 is square root of 48. I times I is I squared. Square root of 48 can be reduced. 48 can be written as 16 times 3. And 16 is a perfect square. 4 times 4 is 16. So I get 4 square root of 3. And I squared is -1. So the final answer is -4 square root of 3. Part B, square root of -5 times square root of -15. When we have square root of negative numbers, we are not allowed to multiply both numbers directly. We must first of all rewrite both numbers in terms of I. Square root of 5, square root of -5 can be written as square root of 5 times I. And square root of -15 can be written as square root of 15 times I. Rewrite both numbers in terms of I. Then we can multiply the square root. Square root of 5 times square root of 15 is square root of 75. I times I is I squared. Then reduce square root of 75. Square root of 75 can be written as square root of 25 times square root of 3. And we know that square root of 25 is 5. Square root of 3 stays the same. So we get 5 square root of 3 times I squared. And we know that I squared is -1. 5 radical 3 times -1 is -5 radical 3. Part C, 3 minus 2i times 4 plus 3i. So here we can distribute first. 3 times 4 is 12. 3 times 3i is 9i. -2i times 4 is -8i. And -2i times 3i is -6i squared. Then combine like terms. 9i minus 8i is 1i. Minus 6 times I squared. And we know that I squared is -1. -6 times -1 is +6. And we know that 12 plus 6 is 18. So the final answer is 18 plus I. Part B, 2 minus 5i squared. Here, 2 minus 5i squared can be written as 2 minus 5i times itself. 2 minus 5i squared can be written as 2 minus 5i times itself. Then distribute. 2 times 2 is 4. 2 times -5i is -10i. And again, -5i times 2 is -10i. -5i times -5i is +25i squared. Then combine like terms. -10i plus -10i is -20i. Plus 25i squared. We know that I squared is -1. So we get 4 minus 20i. 25 times -1 is -25. So we get 4 minus 20i minus 25. Then combine like terms. 4 plus -25 is -21. I get -21 minus 20i. That's the final answer in the simplest form. -21 minus 20i. Part E, we have 4 minus 5i over 2i. In order to write the answer in the standard form, if the bottom contains I first of all multiply top and the bottom by I. I try to make the bottom to be a real number. If the bottom has only one term and contains I, I multiply top and the bottom by I. Then on the top, distribute I to the numerator. I get 4i minus 5i squared. On the bottom, if I distribute I get 2i squared. We know that on the top, I squared is -1. -5 times -1 is +5. On the bottom, I squared is -1. 2 times -1 is -2. So we get, take top divided by bottom. 4i divided by -2 is -2i. Plus 5 divided by -2 is -5/2. For the final answer in the standard form, we must write the real number first. Write the real part first. Put the imaginary part on the back. So the final answer in the standard form is -5/2 minus 2i. That's the final answer in the standard form. Write the real part first. Put the imaginary part in the back. F. 3 plus 2i over 1 minus 4i. In order to put the answer in the standard form, if the bottom has two terms, we multiply top and the bottom by the conjugate of the denominator. So I get 3 plus 2i over 1 minus 4i times the conjugate of the denominator. Conjugate means the real part stays the same, and for the imaginary part, change the sign. -4i become +4i. Multiply the conjugate to the top and the bottom. On the top, we distribute. 3 times 1 is 3. 3 times 4i is 12i. 2i times 1 is 2i. 2i times 4i is +8i squared. On the bottom, 1 minus 4i times 1 plus 4i. Let match the formula of difference. Let match the formula, the difference of perfect squares. A plus b times a minus b. That equal to a squared minus b squared. That this formula is called the difference of perfect squares. And the bottom, when we multiply the conjugate, we match this formula here. So we get 1 squared minus 4i squared. Then simplify the top and the bottom. On the top, combine like terms. 12i plus 2i is 14i. I squared is -1. A times -1 is -a. On the bottom, 1 squared is 1. 4i squared, 4 squared is 16. I squared is -1. For 4i squared, 4 squared is 16. I squared is -1. Then multiply. Combine like terms on the top and the bottom. On the top, 3 plus -8 is -5 minus 14i. On the bottom, -16 times -1 is +16. 1 plus 16 is 17. Then, for the final answer in the standard form, take a real number, divide by 17, and get -5/17. Then, take the complex part, divide by 17, I get -14/17 times I. Number 2, solve each of the following equations. Part A, x squared minus 4x minus 2 equals 0. How can we solve this equation? In order to solve this equation, we can try to solve the equation by factoring. But this equation is not factorable. If it's not factorable, we can either solve the equation by completing square or by quadratic formula. Here, let's try to solve it using quadratic formula. Quadratic formula is -b plus or minus square root of b squared minus 4ac all over 2a. In this equation, a is 1, b is -4 and c is -2. Plotting a, b, c, solve for x. Here x is -b, which is -4, plus minus square root of b squared minus 4 times a times c. C is -2. All over 2a. A is 1. Then simplify. -4 is +4. Plus or minus. -4 squared is 16. Then 4 times 1 times -2 is -a. Minus -a is the same as plus a. On the bottom, we get 2 times 1. 2 times 1 is 2. Then simplify. We get 4 plus or minus square root of 24. Next, let's reduce square root of 24. Square root of 24 can be written as square root of 4 times square root of 6. Do we know that square root of 4 is 2? We leave square root of 6 the same. So x is 4 plus or minus 2 square root of 6 over 2. Then for the final answer, 4 divided by 2 is 2. And 2 square root of 6 divided by 2 is square root of 6. So the final answer is either s equal to 2 plus square root of 6 or s equal to 2 minus square root of 6. There are two solutions. That's the final answer. Part B. 4x squared minus 11x plus 6 equal to 0. When we have a quadratic equation, we can first of all try to solve the equation by factoring. Is it factorable here? Let's try to use AC method first. Here, a times c. 4 times 6 is 24. Can we find two numbers that multiply to be 24 and add to be -11? We can try to use 3 and a. We know that 3 times a is 24, but we try to get -11 here, so we use -3 and -a. -3 times -a is +24, and -3 plus -a is -11. So it's factorable. This equation is factorable. I first of all rewrite the middle term using these two numbers. Rewrite the middle term using these two numbers. So 11x can be written as -3x minus ax, then plus 6 equal to 0. First of all, rewrite the middle term using these two numbers. Next, factor by grouping. If I group the first two terms together, I get 4x squared minus 3x. If I group last two terms together, I get ax, -ax plus 6. Then take out common factors. For the first two terms, common factor is x. If I pull out x, I get 4x minus 3. For the second half, for -ax and 6, the common factor here is 2. Since the first term is negative, pull out negative sign. So take out -2. -a divided by -2 is +4. +6 divided by -2 is -3. So here you can see that 4x minus 3 is a common factor. 4x minus 3 is a common factor. If I pull out 4x minus 3, what's left is x minus 2. If I pull out 4x minus 3, what's left is x minus 2. Then, after factoring, set each factor equal to 0. I get 4x minus 3 equal to 0, and x minus 2 equal to 0. Then solve the first equation. I get 4x equal to 3, and s equal to 3 over 4. If I solve the second equation, I get s equal to 2. So those are the solutions to the second equation. Part C. S squared minus 2x plus a. When we have a quadratic equation, we try to first of all try to solve the equation by factoring. This equation looks like it's not factorable. We cannot find two numbers that multiply to be a and to be -2. That seems impossible. So let's try to solve the equation using quadratic formula. Here, a is 1, b is -2, c is a. Use quadratic formula. The formula says -b plus or minus b squared minus 4ac all over 2a. Then simplify. -2 is +2. Under square root, -2 squared is 4. Minus 4 times 1 is 4. And then 4 times a is 32. Over, on the bottom, 2 times 1 is 2. Then, keep simplifying. I get 2 plus or minus, under square root, 4 minus 32 is -28. How do we simplify square root of -28? Square root of -28 can be written as square root of 28 times square root of -1. Square root of -1 is I. Square root of 28 can be written as square root of 4 times square root of 7. And we know that square root of 4 is 2. We leave square root of 7 the same. So the final answer is 2 square root of 7 times I. 2 square root of 7 times I over 2. And then we know that 2 over 2 is 1. 2 square root of 7 over 2 is square root of 7. I stays the same. So there are two solutions. X equal to 1 plus square root of 7 times I. And x equal to 1 minus square root of 7 times I. Part D. 3x squared plus 6x plus 4 equal to 0. When we have a quadratic equation, we can first of all try to solve the equation by factoring. Is it factorable here? Is it factorable? Let's try to use AC method. A times C, 3 times 4 is 12. Can we find two numbers that multiply to be 12 and add to be 6? It seems impossible. We cannot find two numbers that multiply to be 12 and add to be 6. That seems impossible. That means it's not factorable. If a quadratic equation is not factorable, we can either try to solve an equation by completing square or by quadratic formula. In general, completing square is harder. Let's try to solve an equation by quadratic formula. Here, A is 3, B is 6, C is 4. Use quadratic formula. S equal to -b plus or minus b squared minus 4ac all over 2a. Then simplify. -6 stays the same. Under square root, 6 squared is 36. 4 times 3 is 12. 12 times 4 is 48. Over on the bottom, 2 times 3 is 6. Then under square root, 36 minus 48 is -12. How can we simplify square root of -12? Square root of -12 can be written as square root of 12 times square root of -1. Square root of 12 can be rewritten as square root of 4 times square root of 3. And we know that square root of 4 is 2. Square root of 3 cannot be reduced. I leave it the same. Square root of -1 is I. That means square root of -12 is 2 square root of 3 times I. So s is negative 6 plus or minus 2 square root of 3 times I, all over 6. Then simplify. Negative 6 over 6 is negative 1. 2 radical 3 over 6. I can divide top and bottom by 2. I make square root of 3 over 3 times I. For 2 square root of 3 over 6, I divide top and bottom by 2. I get square root of 3 over 3 times I. So the final answer is negative 1 plus square root of 3 over 3 times I. Or s equal to negative 1 minus square root of 3 over 3 times I. Part E. AS cube plus 27 equal to 0. This is a third degree equation. In general, for third degree equation, there are 3 solutions. Here, how can we find all 3 solutions? First of all, let's try to factor using the difference of the sum of perfect cubes. We know that a cube plus b cube is always a plus b times a squared minus ab plus b squared. That's called the sum of perfect cubes. The other one is a cube minus b cube equal to a minus b times a squared plus ab plus b squared. That's called the difference of perfect cube. That's called the sum of perfect cube. Here, as cube can be written as 2x to the power of 3, because 2 to the power of 3 is a. 27 can be rewritten as 3 to the power of 3. Then, if we match the formula, we can see that 2x represents a, 3 represents b. So apply the formula. We have a plus b, 2x plus 3 times a squared minus ab plus b squared. Here a squared is 4s squared minus ab. A times b is 6x plus b squared. 3 squared is 9. It's subtraction in the middle. Minus ab minus 6x plus 9. Then, after factoring, set each factor equal to 0. After factoring, set each factor equal to 0, and then solve each equation individually. I set 2x plus 3 equal to 0, and 4x squared minus 6x plus 9 equal to 0. For the first equation, I can first of all subtract 3 from both sides. I get 2s equal to negative 3, and then divide both sides by 2. I get s equal to negative 3 over 2. That's the solution to the first equation. For the second equation, this is a second degree, this is a quadratic equation. We can try to solve the equation by factoring first. Let's try AC method. 4 times 9 is 36. Can we find two numbers that multiply to be 36 and add to be negative 6? Here it seems impossible. If it's impossible, that means this function, this equation is not factorable. If it's not factorable, we can try to use quadratic formula. So a is 4, b is negative 6, c is 9. Use quadratic formula. We have s equal to negative b plus or minus b squared minus 4ac all over 2a. Then simplify. Negative 6, double negative is positive. Under square root, negative 6 squared is 36. Then multiply the second part. 4 times 4 is 16. 16 times 9 is 144. On the bottom, 2 times 4 is 8. Then simplify square root. 36 minus 144 is negative 108 over 8. Next, simplify square root of negative 108. Square root of negative 108 can be rewritten as square root of 108 times square root of negative 1. And 108 can be written as 36 times 3. Square root of 36 is 6. Square root of 3 cannot be reduced, so I leave it the same. Square root of negative 1 is I. So square root of negative 108 is 6 square root of 3 times I. Here I get 6 square root of 3 times I, all over 8. Then let's divide. Separate the real part and the imaginary part. For the real part, I get 6 divided by 8. 6 over 8 is the same as 3 over 4. For the real part, I get 6 over 8. We know that 6 over 8 can be reduced as 3 over 4. Plus or minus. For the imaginary part, I get 6 radical 3 over 8. For 6 radical 3 over 8, I can divide top and bottom by 2. I get 3 radical 3 over 4 times I. Then for the final answer, we have s equal to 3 over 4 plus 3 radical 3 over 4i, or s equal to 3 radical 4 minus 3 radical 3 over 4i, and plus the first solution, s equal to negative 3 over 2. There are totally 3 solutions. In general, for a third-degree equation, usually there are 3 solutions. For a third-degree equation, usually there are 3 solutions. Part F, 81 x to the power 4 minus 16. This is a 4th-degree equation. In general, there are 4 solutions. So let's find all 4 solutions. Let's solve an equation by factoring. We know that 81 is a perfect square. It's 9 times 9. S to the power 4 is also a perfect square, because s squared times s squared is s to the power 4. So 81 s to the power 4 can be rewritten as 9s squared squared. 16 can be rewritten as 4 squared. So they are both perfect squares. When we have different perfect square, the formula is a squared minus b squared equal to a plus b times a minus b. Then apply the formula here. I get 9s squared plus 4 times 9s squared minus 4, because 9s squared represents a and number 4 represents b. Next, keep factoring. The first equation, first factor, 9s squared plus 4, that's not factorable. But the second part is factorable. 9s squared minus 4. 9s squared can be rewritten as 3x squared. And 4 can be rewritten as 2 squared. Again, that's difference of perfect squares. Here, 3x represents a, number 2 represents b. Applying the formula, I get a plus b times a minus b. So I get 3x plus 2 times 3x minus 2. After factoring completely, set each factor equal to 0. So I have 9x to the power 4, 9x to the power 2 minus 4. 9x squared plus 4 is 0. 3x plus 2 equal to 0. And 3x minus 2 equal to 0. For the first equation, I can first of all subtract 4 from both sides. I get 9s squared equal to negative 4. Then I can divide both sides by 9. I get s squared equal to negative 4 over 9. Then in order to get s by itself, take square root on both sides. When we take square root, always a plus or minus sign in the front. I get plus or minus negative 4 over 9, square root of negative 4 over 9. Next, simplify square root of negative 4 over 9. For square root of negative 4 over 9, it can first of all be rewritten as square root of 4 over 9 times square root of negative 1. Square root of 4 over 9 is 2 over 3, because square root of 4 is 2, square root of 9 is 3, and square root of negative 1 is I. So if I simplify square root of negative 4 over 9, I get 2 over 3 times I. Here, plus minus sign in the front stays the same. So I get two solutions, s equal to 2 over 3i, or s equal to negative 2 over 3i. I get two solutions from this equation. In the second equation, I can subtract 2 from both sides. I get 3x equal to negative 2. And then divide both sides by 3. I get s equal to negative 2 over 3. That's another solution. For the third equation, I can first put add 2 to both sides. I get 3s equal to 2. And then divide both sides by 3. S equal to 2 over 3. So I get 1, 2, 3, 4. That's totally 4 solutions. There are totally 4 solutions. In general, for a 4-degree equation, usually there are 4 solutions. Number 3, graph each of the following quadratic functions. Please indicate the vertex, axis of symmetry, and s and y intercepts. Part A, f of x is x squared minus 6x plus 5. We know that the graph of quadratic function is always a parabola. It's either open upward or open downward. The graph of a quadratic function is always a parabola. It's either open upward or open downward. For this quadratic function here, the coefficients are a, b, and c. Here a is 1, b is negative 6, c is 5. If a is positive, the parabola is open upward. If a is negative, parabola is open downward. Here a is 1, which is positive, so the parabola is open upward. Since a equal to 1, which is greater than 0, the parabola is open upward. Next, let's find the axis of symmetry. For axis of symmetry, the formula is s equal to negative b over 2a. For axis of symmetry, the formula is s equal to negative b over 2a. A is 1, b is negative 6. Let's plug in. We get negative 6 over 2 times a. On the top, negative 6, double negative is positive. We get 6 over 2, which is 3. So that's an axis of symmetry. Next, let's find the vertex. We know that vertex always locate an axis of symmetry. Vertex always locate an axis of symmetry. So for the vertex, its x coordinate is 3. For its y coordinate, we plug 3 into the function, into the original function. If I plug in 3, I get 3 squared minus 6 times 3 plus 5. 3 squared is 9. 6 times 3 is 18 plus 5. 9 minus 18 is negative 9. Negative 9 plus 5 is negative 4. So the vertex here is 3, negative 4. Vertex always locate an axis of symmetry. So the x coordinate is the same as axis of symmetry. For its y coordinate, we plug x into the original function. So that's the vertex 3, -4. Next, let's find the s and y intercepts. For the s-intercept, we set y equal to 0, which means set the entire function f of x equal to 0. So we get x squared minus 6x plus 5 equal to 0. Then solve the equation by factoring. I get s minus 2 times s minus 1 times s minus 5. -1 times -5 is positive 5, and -1 plus -5 is positive 6. It's negative 6. Then solve, set each factor equal to 0. Solve each equation individually. We get s equal to 1 and s equal to 5. So the s-intercept is 1, 0, and 5, 0. For the y-intercept, set s equal to 0. For the y-intercept, set s equal to 0. If I plug in 0 for x, I get y equal to f of 0. Plug in 0 for x, I get 0 squared minus 6 times 0 plus 5. We know that 0 squared is 0. 6 times 0 is 0 plus 5. I get y equal to 5. So the y-intercept is 0, 5. So that's an s-intercept, that's a y-intercept, that's a vertex, that's an axis of symmetry. And we know that the parabola is open upward. Based on this information, let's sketch the graph. S-intercept is 1, 0, 5, 0. One, 0, and 5, 0. 2, 3, 4, 5. Y-intercept is 0, 5. 1, 2, 3, 4, 5. That's the y-intercept. Vertex is 3, -4. X coordinate is 3, y coordinate is -4. 1, 2, 3. 1, 2, 3, 4. And that's an axis of symmetry. S equal to 3. That's an axis of symmetry. The parabola is open upward. It must go through all these points. So the graph looks like this. Connect these points, use smooth curves. A parabola is a smooth curve. Connect these points, use smooth curves. So that's a graph of a parabola. Y equal to f of x equal to s squared minus 6x plus 5. Part B. F of x equal to -2s squared plus ax minus 6. Here a is -2, b is a, c is -6. Since a is less than 0, since a is -2, which is negative, that means the parabola is open downward. Next, let's find axis of symmetry. The formula is S equal to negative b over 2a. Plugging a and b. Here b is a is negative 2. I get negative a over negative 4. Negative a over negative 4 is positive 2. So the axis of symmetry is S equal to 2. Next, let's find the vertex. Since the vertex located an axis of symmetry, so its S coordinate is the same as axis of symmetry. Since the vertex located an axis of symmetry, its S coordinate is the same as the axis of symmetry. So S equal to 2. For the Y coordinate, we plug 2 into the original function. For the Y coordinate, plug 2 into the original function. I get negative 2 times 2 squared plus a times 2 minus 6. 2 squared is 4 plus a times 2 minus 6. Negative 2 times 4 is negative a. A times 2 is 16 minus 6. Negative a plus 16 is a. A take away 6 is 2. So the vertex is 2, 2. The vertex is 2, 2. Next, let's find S and Y intercepts. For the S-intercept, we set y equal to 0, which means set the entire function equal to 0. Set y equal to 0. Y is f of x. So set f of x equal to 0, which means we have negative 2s squared plus ax minus 6 equal to 0. Solve the equation for x. For this equation, I can first of all divide both sides by negative 2. To make it easier, I can first of all divide both sides by negative 2. If I divide both sides by negative 2, I get s squared minus 4x plus 3. A divided by negative 2 is negative 4. Negative 6 divided by negative 2 is positive 3. Then solve the equation by factoring. I have x minus 1 times x minus 3. Negative 1 times negative 3 is positive 3. And negative 1 plus negative 3 is negative 4. Next, set each factor equal to 0. Then solve the equation for x. I get s equal to 1 and s equal to 3. So the s coordinate is 1, 0 and 3, 0. For the y-intercept, I set s equal to 0, which means I plug in 0 for x. If I plug in 0 for x, I have y equal to f of 0. If I plug in 0 for x, I get negative 2 times 0 squared plus a times 0 minus 6. Negative 2 times 0 squared is 0. A times 0 is 0 minus 6. I get negative 6. So the y-intercept is 0, negative 6. That's an s-intercept and that's a y-intercept. Next, based on this information, sketch a graph. S-intercept is 1, 0 and 3, 0. So those are the S-intercepts. Y-intercept is 0, negative 6. 1, 2, 3, 4, 5, 6. That's the y-intercept. The vertex is 2, 2. S coordinate is 2. Y coordinate is also 2. Is here. That's the vertex. Axis of symmetry is s equal to 2. That's an axis of symmetry. Then sketch a smooth curve passing through these points. A parabola is always smooth. It's always a smooth curve. A parabola is always a smooth curve. So graph a smooth curve passing through these points. That's an That's an axis of symmetry. So the graph is symmetrical over this line. The graph is symmetrical over this line. That's the parabola. Number 4. Complete the square for each of the following quadratic functions and find their maximum or minimum values. Part A. f of x is 3x squared plus 12x minus 5. Let's complete the square first. If we try to complete square for quadratic function, first step, we group all x together. Group the term with x together. I get 3x squared plus 12x minus 5. Next, if there's a coefficient in front of x squared, pull out the coefficient first. If there's a coefficient in front of x squared, pull out the coefficient first. If I pull out 3, I get x squared plus 4x minus 5. So if there's a coefficient in front of x squared, pull out the coefficient first. Next, we try to add a term here to make perfect square. Try to add a term here to make perfect square here. What should we add? So take the second term, take the second coefficient. Take the second coefficient, divide by 2, I get 2. Then square this number. 2 squared is 4. So add 4 here to make perfect square. When we add 4, we must subtract 4 at the same time to keep it in balance. When we add 4, we must subtract 4 at the same time to keep it in balance. Then rewrite the first 3 terms using a perfect square. X squared plus 4x plus 4 is a perfect square. If we factor, we can write it as x plus 2 times x plus 2. Because 2 times 2 is 4, and 2 plus 2 is also 4. 2 times 2 match the last term, and 2 plus 2 match the middle term. So this can be written as s plus 2 squared. A shortcut is we can use this number, positive 2. Write it as s plus 2 squared. Then minus 4 stays the same. Minus 5. Next, distribute 3 to both of them. I get 3 times s plus 2 squared minus 3 times 4 is 12. Then combine like terms. I get 3 times s plus 2 squared minus 17. That's how we complete square for function f. And after complete square, we know that the vertex is -2, -17. After we complete square, try to match the formula. F of x equal to a times x minus h squared plus k. Since we have -h here, for this value, take the opposite sign. And k is positive, we keep the value itself. Since h is negative, take the opposite sign. For positive 2, take -2. And -17, take the exact value. That's the vertex. Also, we know that here, a is 3. If a is greater than 0, the parabola is open upward. Since a is 3, a is greater than 0, the parabola is open upward. If a parabola is open upward, that means it has a minimum. If a parabola is open upward, it has a minimum. If it's open downward, it has a maximum. In this case, since a is greater than 0, the parabola is open upward, so it has a minimum. The maximum or minimum always located in a vertex. For any parabola, the maximum or minimum always locate in a vertex. And for maximum minimum, we only use the y coordinate. For maximum minimum, we only use the y coordinate. Here the y coordinate is -17. That's how we find the maximum or minimum of a parabola. Part B. F of x is x squared minus 3x plus 1. So, in order to complete square, first of all, we group the term of x together. I get x squared minus 3x plus 1. Next, we try to add a term here to make perfect square. What should we add? What should we add here to make perfect square? So take the middle coefficient. Take -3 divided by 2. That's -3 over 2. Then square this number. -3 over 2, when we square, we get 9 over 4. Double negative is positive. We get 9 over 4. So add 9 over 4 here and subtract 9 over 4 at the same time to make perfect square. When we add 9 over 4, we must subtract 9 over 4 at the same time to keep it in balance. Then factor the first three terms. X squared minus 3x plus 9 over 4. This is a perfect square trinomial. We can use this number as a shortcut to make perfect square. So we get x minus 3 over 2 squared. That's a perfect square. That's a perfect square. Minus 9 over 4 plus 1. Then combine like terms. 9 over 4 plus 1, what do we get? -9 over 4 plus 1. We can rewrite 1 as 1 over 1. Then find their common denominators. For 4 and 1, the least common multiple is 4. So for the first fraction, I multiply top and bottom by 4. I get -9 over 4 plus 4 over 4, which is -5 over 4. Combine like terms, I get -5 over 4, which means the vertex of the parabola. The vertex of the parabola is 3 over 2, comma 5 over 4. Since in the standard form, h is negative, k is positive. So for h, take an opposite value. For k, take the same value, -5 over 4. That's the vertex. And we know that here a is 1. A is 1, which is greater than 0. If a is greater than 0, the parabola is open upward. If the parabola is open upward, f has a maximum, f has a minimum. If a is less than 0, then the parabola is open downward. If parabola is open downward, it has a maximum. In this case, since a is less than 0, parabola is open upward. Since a is greater than 0, parabola is open upward. So function f has a minimum. The maximum or minimum always located in a vertex. And for the maximum or minimum, we only use the y coordinate. Here the y coordinate is -5 over 4. That's the minimum of this parabola. Number 5. Divide the following polynomials and find a quotient and a remainder. Part A. 2x to the power 4 plus 2x cubed minus 10x squared plus 9x plus 15 divided by x plus 3. For polynomial division, we have two choices in general, the synthetic division or long division. In general, synthetic division is easier. However, in order to use synthetic division, the divisor must be in the form of x minus c. In order to use synthetic division, the divisor must be in the form of x minus c. Here, the divisor x plus 3 can be rewritten as x minus negative 3. So for part A, we can use synthetic division instead of long division. So let's do synthetic division. For synthetic division, first step, put a coefficient of x, put a coefficient of polynomial on the line. Make sure write in order, from larger power to smaller power. 2 is a coefficient of x to the power 4. Next, write down 2. That's coefficient of x cubed. Minus 10, that's coefficient of x squared. 9, that's a coefficient of x. And 15. 15 is a constant term. And then divided by negative 3. We must divide by this number c. Here c is negative 3. So for synthetic division, first step, bring 2 down. Negative 3 times 2 is negative 6. 2 times negative 6 is negative 4. Negative 3 times negative 4 is positive 12. Negative 10 plus 12 is 2. Negative 3 times 2 is negative 6. 9 plus negative 6 is 3. Negative 3 times 3 is positive 9. It's negative 9. And 15 plus negative 9 is 6. That's a remainder. That's a remainder. For the quotient, this is the quotient. Number 3 is the coefficient of the constant term. 2 is the coefficient of x. Negative 4 is the coefficient of x squared. 2 is the coefficient of x cubed. Then multiply. I get 2x cubed minus 4x squared plus 2x plus 3 times 1 is 3. That's the quotient. Usually we use q of x to represent quotient. And we use r of x to represent remainder. So that's the quotient, that's the remainder. Part B. Two x to the power 4 plus 5x cubed minus 2x squared plus 6x minus 4 divided by 2x plus 1. Since the denominator is not in the form of s minus c, here for part B, we must use long division. Since the denominator is not in the form of s minus c, so for part B, we must use long division. So let's do long division here. Put a dividend here. The numerator is a dividend, put it here. I have 2x to the power 4 plus 5x cubed minus 2x squared plus 6x minus 4 divided by 2x plus 1. So for long division, first of all, let's compare the leading term. 2x to the power 4 and 2x. What should we multiply to 2x to make 2x to the power 4? What should we multiply to 2x to make 2x to the power 4? Let's do division. 2x to the power 4 divided by 2x is s cubed. If I divide leading term, I get s cubed. That means 2x times s cubed is 2x to the power 4. So put s cubed on the top. Line up exponent. Put it here. Then multiply s cubed to both terms. I get 2x to the power 4 plus s cubed. Then subtract. 2x to the power 4 minus 2x to the power 4 and get cancelled. 5s cubed minus s cubed is 4s cubed. Bring the rest down. I get negative 2x squared plus 6x minus 4. Next, compare the leading term. What should we multiply to 2x to make 4s cubed? What should we multiply to 2x to make 4s cubed? So here, to division, take a leading term, divide by leading term. I take 4s cubed divided by 2x, which is 2s squared. That means 2x times 2s squared would be 4s cubed. So put 2s squared on the top. Make sure line up exponent. I get plus 2s squared. Then multiply 2s squared to both of them, to both terms. I get 4s cubed plus 2s squared. Then subtract. 4s cubed minus 4s cubed, make it cancel. Negative 2s squared minus 2s squared is negative 4s squared. Bring the rest down. Next, compare the leading term. What should we multiply to 2x to make negative 4s squared? What should we multiply to 2x to make negative 4s squared? So here let's do division. Let's divide the leading term. Take negative 4s squared divided by 2x. We know that negative 4s squared divided by 2x is negative 2x, which means 2x times negative 2x will be negative 4s squared. So put negative 2x on the top. Make sure line up the exponent. Then multiply negative 2x to 2x plus 1. I get negative 4s squared plus minus 2x. Then subtract. Negative 4s squared minus negative 4s squared. Double negative is positive. So negative 4s squared plus 4s squared, they can cancel. Next, take 6x minus negative 2x. Double negative is positive. So I get 6x squared, 6x plus 2x, which is ax. Bring 4 down. I got minus 4 here. Next, compare leading term. What should I multiply to 2x to make ax? So here, let's do division. Let's divide leading term. Take ax divided by 2x. And we see that here, ax divided by 2x is 4. That means 2x times 4 will be ax. So put 4 here. That's a constant term. Then multiply 4 to both of them. 4 times 2x is ax. 4 times 1 is 4. Then subtract. Ax minus ax can cancel. Negative 4 minus 4 is negative a. That's a remainder. That's a quotient, that's a remainder. So the quotient q of x is s cubed plus 2s squared minus 2x plus 4. The remainder r of x is negative a. Usually we use q of x represent the quotient, r of x represent the remainder. Part C. X to the power 5 minus 2x to the power 4 minus 4s cubed plus 4s squared plus 4x plus 1 divided by s squared minus 3x plus 1. Since the denominator cannot be written in the form of s minus c, we must use long division. We cannot use synthetic division here. We must use long division. So let's do long division here. X to the power 5 minus 2x to the power 4 minus 4s cubed plus 4s squared plus 4x plus 1 divided by s squared minus 3x plus 1. If the divisor is not in the form of s minus c, we must use long division. We cannot do synthetic division. So let's do long division here. First of all, compare leading term. What should I multiply s squared to make s to the power 5? What should I multiply to s squared to make s to the power 5? Let's do long division. Take s to the power 5 divided by s squared, I get s cubed. That means if I multiply s squared by s cubed, I can make s to the power of 5. So put s cubed on the top. Make sure line up exponent. Line up exponent. So I put s cubed here. Then multiply s cubed to the divisor. S cubed times s squared is x to the power of 5. S cubed times negative 3x is negative 3x to the power of 4. S cubed times 1 is s cubed. Then subtract. S to the power of 5 minus s to the power of 5, they can cancel. Negative 2s to the power of 4 minus negative 3s to the power of 4. Double negative is positive. So negative 2s to the power of 4 plus 3s to the power of 4. I get 1s to the power of 4. Then negative 4s cubed minus s cubed is negative 5s cubed. Bring the rest down. I get plus 4s squared plus 4x plus 1. Next, compare a leading term. What should I multiply to s squared to make x to the power of 4? What should I multiply to s squared to make x to the power of 4? Let's do division. Let's divide leading term. If I take x to the power of 4 divided by s squared, I get s squared. That means s squared times s squared will be x to the power of 4. So put s squared on the top. Make sure line up the exponent. Line up the exponent. Then multiply s squared to the entire divisor. S squared times s squared is x to the power of 4. S squared times negative 3x is negative 3x cubed. S squared times 1 is s squared. Then subtract. X to the power of 4 minus s to the power of 4, they can cancel. Negative 5s cubed minus negative 3s cubed. Double negative is positive. Negative 5s cubed plus 3s cubed is negative 2s cubed. 4s squared minus s squared is 3s squared. Bring the rest down. Next, compare a leading term. What should I multiply to s squared to make negative 2s cubed? What should I multiply to s squared to make 2s cubed? Let's do long division. Let's do division here. Take negative 2s cubed divide by s squared. I get negative 2x. Put negative 2x on the top. Then multiply negative 2x to the entire divisor. I get negative 2s cubed plus 6s squared minus 2x. Then subtract. Negative 2s cubed minus negative 2s cubed. They can cancel. 3s squared minus 6s squared. That's negative 3s squared. 4x minus negative 2x. Double negative is positive. So we get 4x plus 2x. X plus 2x is 6x. Bring number 1 down. Next, again, compare leading term. What should I multiply to s squared to make negative 3s squared? Let's do division. Take negative 3s squared divide by s squared. Negative 3s squared divided by s squared is negative 3. So put negative 3 on top. Then multiply negative 3 to the entire divisor. I get negative 3x squared plus 9x minus 3. Then subtract. Negative 3x squared minus negative 3x squared. Double negative is positive. And they can cancel. 6x minus 9x is negative 3x. 1 minus negative 3. Double negative is positive. So we get 1 plus 3, which is 4. So the remainder is negative 3x plus 4. And that's the quotient. Here the quotient is s cubed plus s squared minus 2x minus 3. That's the quotient. Remainder r of x is negative 3x plus 4. So that's the remainder That's a quotient. Part D. X minus 5x cubed plus 2x to the power of 5 plus a divided by x plus 2. For part D, since the divisor is in the form of x minus c, I can use synthetic division instead of long division. So here, the divisor x plus 2 can be rewritten as x minus negative 2. Let's use synthetic division. First step, put a coefficient on the line. Now be very, very careful. This polynomial is not in descending order. The term of the highest power is x to the power of 5. Then next, write down all lower powers start from x to the power of 5. Write down all lower powers start from x to the power of 5. X to the power of 5 is the first term. Next term will be x to the power of 4. Next will be x cubed, x squared, x to the power of 1, and x to the power of 0 is 1. Put their coefficient in the first line. For x to the power of 5, coefficient is 2. For x to the power of 4, it's missing, so it's like 0. If x to the power of 4 is missing, its coefficient is 0. And for x cubed, its coefficient is negative 5. For x squared is missing, so its coefficient is 0. For x, coefficient is 1, and the constant is a. Then divided by negative 2. Since negative 2 represents c, so divide by negative 2. For synthetic division, first step, bring 2 down. Take negative 2 times 2, we get negative 2. We get negative 4. 0 plus negative 4 is negative 4. Then multiply. Negative 2 times negative 4 is positive a. Negative 5 plus positive a is positive 3. Then multiply. Negative 2 times 3 is negative 6. 0 plus negative 6 is negative 6. Negative 2 times negative 6 is positive 12. 1 plus 12 is 13. Negative 2 times 13 is negative 26. Adding up. Negative a plus negative 26 is negative 18. That's the remainder. So the remainder is negative 18. This is the quotient. For the quotient, 13 is a constant term. Negative 6 is the coefficient of x. 3 is the coefficient of x squared. Negative 4 is the coefficient of x cubed. 2 is the coefficient of x to the power of 4. Then multiply together. Multiply together. The quotient is 2 times x to the power of 4. Negative 4 times x cubed. 3 times x squared. Negative 6 times x. And 13 times 1. That's positive 13. So that's the quotient. And the remainder is negative 18. And for this problem, if you do long division, we must get exactly the same answer. If we do long division, we must get exactly the same answer. But using synthetic division is much, much easier than long division. Number 6. Factor each of the following polynomials completely and find all zeros. Part A. F of x is 2x to the power of 4 plus x cubed minus 14x squared minus 4x plus 24. In order to factor this polynomial completely, let's first of all find some potential zeros first. For potential zeros, let's first of all find P and Q. P is a factor of a constant term. P is a factor of a constant term. Here, constant term is 24. 24 can be written as 1 times 24, or 2 times 12, or 3 times a, or 4 times 6. Those are factors of 24. And each factor could be either positive or negative. So P could be positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, positive negative 8, positive negative 12, or positive negative 24. Those are possible values of P. Next, let's find Q. Q is a factor of the leading coefficient. Leading coefficient is 2. The only factor of 2 is either 1 or 2. The only factor of 2 is either 1 or 2. And each number could be either positive or negative. So those are the values for P and Q. Next, based on P and Q, let's write down all potential rational zeros. I first of all take P divided by Q. 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 4 divided by 1 is 4. 6 divided by 1 is 6. 8 divided by 1 is 8. 12 divided by 1 is 12. 24 divided by 1 is 24. Next, take each P divided by the second Q. 1 divided by 2 is half. 2 divided by 2 is 1. We have 1 already, so don't repeat it, cross them out. 3 divided by 2 is 3 half. 4 divided by 2 is 2. But we have 2 already, so don't repeat, cross them out. 6 divided by 2 is 3. But we have 3 already, don't repeat, cross them out. 8 divided by 2 is 4. We have 4 already, don't repeat, cross them out. 12 divided by 2 is 6. We have 6 already, don't repeat, cross them out. 24 divided by 2 is 12, but we have 12 already, don't repeat, cross them out. So those are all potential rational zeros, which means all rational zeros of this polynomial must be in this form. But which one is the real rational zero? We don't know. We have to test it. So let's test one by one. Let's first of all test positive 1. If 1 is a rational zero, that means I plug in 1, I must get 0. If 1 is a 0, that means when I plug in 1, I must get 0. Let's test. If I plug in 1, I get 2 times 1 to the power 4 plus 1 cube minus 14 times 1 squared minus 4 times 1 plus 24. Then multiply. 1 to the power 4 is 1. 2 times 1 is 2. 1 cube is 1. 1 squared is 1. 14 times 1 is 14. 4 times 1 is 4. Plus 24. 2 plus 1 is 3. 3 minus 14 is negative 11. Negative 11 minus 4 is negative 15. Negative 15 plus 24 is positive 9. We don't get 0. That means 1 is not 0. 1 is not 0. Let's test for negative 1. If I plug in negative 1, I get 2 times negative 1 to the power 4 plus negative 1 cube minus 14 times negative 1 squared minus 4 times negative 1 plus 24. If I plug in negative 1, negative 1 to the power 4 is 1. 1 times 2 is 2. Negative 1 to the power 3 is negative 1. Negative 1 squared is 1. 1 times 14 is 14. Negative 4 times negative 1 is positive 4 plus 24. What do we get here? 2 minus 1 is 1. 1 minus 14 is negative 13. Negative 13 plus 4 is negative 9. Negative 9 plus 24 is 15. 15 is not 0. That means negative 1 is not 0 of this function. Next, let's test for plus or minus 2. Let's test positive 2 first. If we plug in 2, we get 2 times 2 to the power 4 plus 2 cubed minus 14 times 2 squared minus 4 times 2 plus 24. 2 to the power 4 is 16. 2 times 16 is 32. 2 cubed is 8. 2 squared is 4. 4 times 14 is 56. 4 times 2 is 8. Plus 24. Then adding up. 32 plus 8 is 40. 40 minus 56 is negative 16. Negative 16 minus 8 is negative 24. Negative 24 plus 24 is 0. If f of 2 is 0, that means 2 is a 0 of function f. That means 2 is a 0 of function f. Two is a 0 of function f. Then, by factor theorem, we know that if 2 is a 0 of function f, then x minus 2 is a factor of function f. So x minus 2 is a factor of function f. Which means if I take function f divided by s minus 2, there's long division. Next, let's divide. Take function f divided by s minus 2. Since s minus 2 is in the form of s minus c, I can use synthetic division. So let's do synthetic division here. First of all, put the coefficient of function f in the first row. I get 2, 1, negative 14, negative 4, and 24. Put the coefficient of function f in the first row, and then divided by 2. Let's do synthetic division. First of all, I bring 2 down. 2 times 2 is 4. 1 plus 4 is 5. 2 times 4 is 10. Negative 14 plus 10 is negative 4. 2 times negative 4 is negative 8. Negative 4 plus negative 8 is negative 12. And 2 times negative 2 times negative 12 is negative 24. There's no remainder. And the quotient here is 2. Here, negative 12 is constant term. Negative 4 is coefficient of x. 4 is coefficient of x squared. And 2 is coefficient of x cubed. Then multiply. I get 2x cubed plus 5x squared minus 4x minus 12. Negative 12 times 1 is negative 12. That's the quotient, which means f of s equal to s minus 2 times the quotient. This is the quotient. That means f of s equal to s minus 2 times the quotient. So f of x equal to x minus 2 times the quotient. Quotient is 2x cubed plus 5x squared minus 4x minus 12. Now, since this is a third degree polynomial, let's keep reducing. Let me call this g of x. We know that 2 is a 0 of function f. 2 may also be a 0 of function g. Let's test it. If I plug in 2 into function g, I get 2 times 2 cubed plus 5 times 2 squared minus 4 times 2 minus 12. Here, 2 cubed is 8. 8 times 2 is 16. 2 squared is 4. 4 times 4 is 20. 4 times 2 is 8. Together, 16 plus 20 is 36. 36 take away 8 is 28. 28 take away 12 is 16, which is not 0. That means 2 is not 0 of function g. Next, let's test for negative 2. If I plug negative 2 into function g, I get 2 times negative 2 cube plus 5 times negative 2 square minus 4 times negative 2 minus 12. Negative 2 cube is negative 8. Negative 8 times 2 is negative 16. Negative 2 squared is 4. 4 times 5 is 20. Negative 4 times negative 2 is positive 8 minus 12. Together, negative 16 plus 20 is 4. 4 plus 8 is 12. 12 take away 12 is 0. If we get 0, that means negative 2 is a zero function g. Then, by factor theorem, that means x plus 2. That means x minus negative 2. That's the same as x plus 2. X plus 2 is a factor of function g. Since x plus 2 is a factor of function g, that means if I take function g divided by x plus 2, there's no remainder. So let's divide. Let's use syntactic division. First of all, let me put the coefficient of function g in the first row. I get 2, 5, negative 4, negative 12. Divided by negative 2. X plus 2 can be rewritten as x minus negative 2. So divide by negative 2. Use syntactic division. I first of all bring 2 down. Negative 2 times 2 is negative 4. 5 plus negative 4 is 1. Negative 2 times 1 is negative 2. Negative 4 plus negative 2 is negative 6. Negative 2 times negative 6 is positive 12. Negative 12 plus positive 12 is 0. There's no remainder. The quotient here is negative 6. Negative 6 is a coefficient of a constant term. 1 is a coefficient of x. 2 is coefficient of x squared. So multiply together, I get 2x squared plus 1x minus 6. That's the quotient. That's the quotient. Which means g of x equal to x plus 2 times 2x squared plus x minus 6. And f of x is s minus 2 times g of x, which means f of x is s minus 2 times s plus 2 times 2s squared plus x minus 6. Now, this is quadratic equation. This is a quadratic function. We can try to factor this quadratic function using AC method. So for 2s squared plus x minus 6, we can use AC method. Here, a times c is negative 12. 2 times negative 6 is negative 12. Can we find two numbers that multiply to be negative 12 and add to be positive 1? We can try positive 3 and positive 4 and negative 3. When we multiply, we get negative 12. But when we add, we get positive 1. So, rewrite the middle term, use these two numbers. So, positive x can be written as positive 4x, take away 3x. Keep negative 6 the same. Now we get 4 terms. We can factor by grouping. I group the first two terms together and the last two terms together. For the first two terms, take out common factor 2x. If I take out 2x, what's left is s plus 2. For the second half, pull out negative 3. If I take out negative 3, I get x. Negative 6 divided by negative 3 is positive 2. So here we can see that s plus 2 is a common factor. If I pull out s plus 2, I get 2x minus 3. So after factoring, this trinomial can be factored as s plus 2 times 2s minus 3. So f of x equal to x minus 2 times s plus 2 times s plus 2 times 2x minus 3. When we see s plus 2 twice, it can be written as s minus 2 times s plus 2 squared times 2x minus 3. Now here we factor function f completely. In order to find all zeros, we set function f equal to 0. In order to find all zeros of function f, we set function f equal to 0, which means I set each factor equal to 0, and then solve each factor individually. So I get s minus 2 equal to 0, s plus 2 squared equal to 0, and 2x minus 3 equal to 0. If I solve the first equation, I get s equal to 2. For the second equation, I can first of all take square root on both sides. I get s plus 2 equal to 0. And then subtract 2 from both sides. I get s equal to negative 2. For the third equation, I can first of all add 3 to both sides. I get 2s equal to 3. Then divide both sides by 2. I get s equal to 3 over 2. So the zero of function f is 2, negative 2, and 3 over 2. Those are the zeros of function f. Part B, f of x is x to the power 4 minus 4s cubed minus 3s squared plus 14x plus 12. We try to factor f completely and find all zeros. In order to factor f completely, let's first of all find the potential rational zeros of function f first. So for the potential rational zeros, let's first of all find p and q. P is the factor of the constant term. Here the constant term is 12. 12 can be written as 1 times 12, 2 times 6, or 3 times 4. Those are all possibility to form 12. So the factor of 12 are 1, 2, 3, 4, 6, 12. Each factor could be either positive or negative. So P could be either positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, or positive negative 12. Q is the factor of the leading coefficient. The leading coefficient is 1. The only factor of 1 is 1 itself, and 1 could be either positive or negative. A factor could be either positive or negative. So those are the values for P and Q. So the potential rational zero. The potential rational zeros are always in the form of P over Q. So take P divided by Q. 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 4 divided by 1 is 4. 6 divided by 1 is 6. 12 divided by 1 is 12. So those are all potential rational zeros. That means all rational zeros must be these numbers. But which one is rational zeros? Let's test it. Let's first of all test for plus minus 1. If I plug in 1 into function f, I get 1 to the power 4 minus 4 times 1 cubed minus 3 times 1 squared plus 14 times 1 plus 12. 1 to the power 4 is 1. 1 cubed is 1. 1 times 4 is 4. 1 squared is also 1. And 1 times 3 is 3. 14 times 1 is 14. Then plus 12. Then adding up. 1 plus 4, 1 minus 4 is negative 3. Negative 3 minus 3 is negative 6. Negative 6 plus 14 is 8. 8 plus 12 is 20. 20 is not 0. That means 1 is not 0 of function f. Next, let's test for negative 1. If we plug in negative 1, I get negative 1 to the power 4 minus 4 times negative 1 cubed minus 3 times negative 1 squared plus 14 times negative 1 plus 12. Negative 1 to the power 4 is positive 1. Negative 1 cubed is negative 1. And negative 1 times negative 4 is positive 4. Negative 1 squared is 1. 1 times negative 3 is negative 3. 14 times negative 1 is negative 14 plus 12. Then adding up. 1 plus 4 is 5. 5 take away 3 is 2. 2 minus 14 is negative 12. Negative 12 plus 12 is 0. If f of negative 1 equals 0, that means negative 1 is a 0 of function f. negative 1 is a zero of function f. Then by factor theorem, we know that x minus negative 1, which is the same as s plus 1, is a factor of function f. If s plus 1 is a factor of function f, that means if I take function f divided by this factor, there's no remainder. Let's do division here. Since the divisor is in the form of x minus c, I can use synthetic division instead of long division. So first of all, I put the coefficient of function f in the first row. I get 1, negative 4, negative 3, 14, 12. Put coefficient of function f in the first row, divided by s plus 1. S plus 1 can be divided as x minus negative 1. So divide by negative 1. First of all, bring 1 down. Negative 1 times 1 is negative 1. Negative 4 plus negative 1 is negative 5. Negative 1 times negative 5 is positive 5. Negative 3 plus 5 is 2. Negative 1 times 2 is negative 2. 14 plus negative 2 is 12. Negative 1 times 12 is negative 12. Positive 12 plus negative 12, there's no remainder. I get 0. So the quotient here is, this is the quotient. Let me write it back as a polynomial. 12 is the coefficient of the constant term. 2 is coefficient of x. Negative 15 is coefficient of x squared. Negative 4 is coefficient of x squared. 1 is coefficient of x cubed. Then multiply together. I get s cubed minus 5s squared plus 2x plus 12. That's the quotient. That's the quotient when I take function f divided by s plus 1. If that's the quotient, that means f of x equal to s plus 1 divisor times quotient times s cubed minus 5s squared plus 2x plus 12. Since this is a third degree polynomial, we can factor this normally. So let's keep doing division. Let me call this function g. And keep doing division. Let me copy function g over. G of x is s cubed minus 5s squared plus 2x plus 12. We know that negative 1 is a factor of, is a zero of function f. Negative 1 is a zero of function f. It may also be a zero of function g. Let's test negative 1 first. If I plug in negative 1 to function g, I get negative 1 cubed minus 5 times negative 1 squared plus 2 times negative 1 plus 12. Negative 1 cubed is negative 1. Negative 1 squared is 1. 1 times negative 5 is negative 5. 2 times negative 1 is negative 2 plus 12. Adding up. Negative 1 plus negative 4 is negative 6. Negative 6 minus 2 is negative 8. Negative 8 plus 12 is 4, which is not 0. That means negative 1 is not 0 function g. Now let's keep going. Next, let's test for positive 2 and negative 2. If I plug in 2, g of 2 is 2 cubed minus 5 times 2 squared plus 2 times 2 plus 12. 2 cubed is 8. 2 squared is 4. 4 times 4 is 20. 2 times 2 is 4 plus 12. A minus 20 is negative 12. Negative 12 plus 4 is negative 8. Negative 8 plus 12 is 4, which is not 0. Which means 2 is not 0 function g. Let's test for negative 2. If I plug in negative 2 for x, I get negative 2 cubed minus 5 times negative 2 squared plus 2 times negative 2 plus 12. Negative 2 cubed is negative 8. Negative 2 squared is 4. 4 times negative 4 is negative 20. 2 times negative 2 is negative 4 plus 12. Negative 8 plus negative 20 is negative 28. Negative 28 minus 4 is negative 32. Negative 32 plus 12 is negative 20, which is not 0. That means negative 2 is not 0 of function g. Keep going. Let's test for positive 3 and negative 3. If I plug in 3 to function g, I get 3 cubed minus 5 times 3 squared plus 2 times 3 plus 12. And we know that 3 cubed is 27. 3 squared is 9. 9 times 5 is 45. 2 times 3 is 6 plus 12. Here, 27 minus 45 is negative 18. Negative 18 plus 6 is negative 12. And negative 12 plus 12 is 0. If g of 3 equals 0, that means 3 is a 0 function g. Then by factor theorem, we know that x minus 3 is a factor of function g. Which means, if I take function g, divide by s minus 3, there's no remainder. Let's take function g divided by s minus 3. Let me use syntactic division here. I first of all put the coefficient of function g in the first row. I get 1, negative 5, 2, 12. Divide by 3. I first of all bring 1 down. 3 times 1 is 3. Negative 5 plus 3 is negative 2. 3 times negative 2 is negative 6. 2 plus negative 6 is negative 4. 3 times negative 4 is negative 12. And we know that 12 plus negative 12 is 0. There's no remainder. For the quotient here, negative 4 is a coefficient of 1. Negative 2 is a coefficient of x. 1 is a coefficient of s squared. Then multiply together. I get s squared minus 2x minus 4. That's the quotient. That's the quotient. That means function g equal to x minus 3 times the quotient s squared minus 2x minus 4. So function f is s plus 1 times function g. And function g is x minus 3 times s squared minus 2x minus 4. Then what's left here is a quadratic function. For quadratic function, we can try to use AC method. If we use AC method here, can we find two numbers that multiply to be negative 4 and add to be negative 2? It seems impossible. If it's impossible, that means this function is not factorable. This factor here is not factorable. If this is not factorable, we factor function f completely. If this function is not factorable, we factor f completely. Next, find all zeros of function f. So set function f equal to 0. Then set each factor equal to 0. Then solve each factor individually. Solve each equation individually. For the first equation, I can subtract 1 from both sides. I get s equal to negative 1. For the second equation, I can add 3 to both sides. I get s equal to 3. For the third equation, this is a quadratic equation. It's not factorable. We can try to use quadratic formula. So use quadratic formula for this. Quadratic formula is s equal to negative b plus or minus b squared minus 4ac all over 2a. Then plug in. Here, a is 1, b is -2, c is -4. Plug in a, b, c. I get -2 plus or minus square root of -2 squared minus 4 times 1 times -4 all over 2a. A is 1. Then simplify. Double negative is positive. I get positive 2. Square root of -2 squared is 4. -4 times 1 is -4. -4 times -4 is positive 16. Then simplify. I get 2 plus or minus square root of 4 plus 16 is 20. Then simplify square root of 20. Square root of 20 can be written as square root of 4 times square root of 5. Square root of 4 is 2. And we leave square root of 5 the same. Answer is 2 plus or minus 2 square root of 5 over 2. And then for the final answer, take 2 divided by 2, I get 1. 2 square root of 5 divided by 2, I get square root of 5. That means s equal to 1 plus square root of 5, or s equal to 1 minus square root of 5. Together with these two solutions, there are totally 4 solutions. So the zeros is -1, 3, 1 plus square root of 5, and 1 minus square root of 5. Those are the zeros of function f. Part C. F of x is x to the power 4 minus 9x cubed plus 30x squared minus 44x plus 24. We try to factor the function f completely and find all zeros. In order to factor f completely, let's first of all find the potential rational zeros first. Let's first of all find p and q. P is a factor of the constant term. P is a factor of the constant term. Here, the constant term is 24. For 24, 24 can be written as 1 times 24, 2 times 12, 3 times 8, or 4 times 6. That's all possibilities. So the factor of P is 1, 2, 3, 4, 6, 8, 12, 24. Each factor could be either positive or negative. Q is a factor of the leading coefficient. Here, leading coefficient is 1. The only factor of 1 is 1. And this 1 could be either positive or negative 1. So, all potential rational zeros for all potential rational zeros, take p divided by q. 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 4 divided by 1 is 4. 6 divided by 1 is 6. 8 divided by 1 is 8. 12 divided by 1 is 12. 24 divided by 1 is 24. Those are all potential rational zeros. Now, which one is a real zero? Let's test it. Which one is a real zero? Let's test it. Those are the potential rational zeros. Next, let's test which one is the real zeros. If I plug in 1, I get 1 to the power 4 minus 9 times 1 cubed plus 30 times 1 squared minus 44 times 1 plus 24. 1 to the power 4 is 1. 1 cubed is 1. 1 times 9 is 9. 1 squared is 1. 1 times 30 is 30. 44 times 1 is 44. Plus 24. Then adding up. 1 minus 9 is -8. Negative 8 plus 30 is 22. 22 minus 44 is negative 22. Negative 22 plus 24 is 2, which is not 0. That means 1 is not rational 0. 1 is not 0 of function f. Next, let's test for negative 1. If I plug in negative 1, I get negative 1 to the power 4 minus 9 times negative 1 cube plus 30 times negative 1 square minus 44 times negative 1 plus 24. Negative 1 to the power 4 is 1. Negative 1 cube is negative 1. Negative 1 times negative 9 is positive 9. Negative 1 square is 1. 1 times 30 is 30. Negative 44 times negative 1 is negative 40 is positive 44 plus 24. Then adding up, 1 plus 9 is 10. 10 plus 30 is 40. 40 plus 44 is 84. 84 plus 24 is 108, which is not 0. That means negative 1 is not 0 of function f. Next, let's test for 2. If I plug in 2, I get 2 to the power 4 minus 9 times 2 cube plus 30 times 2 square minus 44 times 2 plus 24. 2 to the power 4 is 16. 2 cube is 8. 8 times 9 is 72. 2 square is 4. 4 times 30 is 120. 44 times 2 is 88. Plus 24. Now let's add them up. 16 minus 72 is negative 56. Negative 56 plus 120 is 64. 64 take away 88 is negative 24. Negative 24 plus 24 is 0. If f of 2 is 0, means 2 is a 0 of function f. So 2 is a 0 of function f, which means by factor theorem, which means x minus 2 is a factor of function f. So s minus 2 is a factor of function f by factor theorem. That means if I take function f divided by s minus 2, that's the remainder. If I take function f divided by s minus 2, that's the remainder. Now let's take function f divided by s minus 2. Here I use synthetic division. First of all, put the coefficient of function f in the first row. The coefficient here is 1, negative 9, 30, negative 44, and 24. And for s minus 2, that's in the form of s minus c. Here c is 2. So divide by 2. Let's use synthetic division. First of all, bring 1 down. 2 times 1 is 2. Negative 9 plus 2 is negative 7. 2 times negative 7 is negative 14. 30 plus negative 14 is 16. 2 times 16 is 32. Negative 44 plus 32 is negative 12. 2 times negative 12 is negative 24. 24 plus negative 24 is 0. So the remainder is 0. And the quotient, this is the quotient. Next, let me write quotient back as a polynomial. Negative 12 is coefficient of 1. 16 is coefficient of x. Negative 7 is coefficient of s squared. 1 is coefficient of s cubed. Then multiply together, I get 1s cubed minus 7s squared plus 16x minus 12. 12 times 1 is negative 12. That's the quotient. If that's the quotient, that means function f equal to s plus 2 times the quotient. So f of x equal to s minus 2 times the quotient. S cubed minus 7s squared plus 16x minus 12. Since this is a third degree polynomial, it's not easy to factor this directly. So let me call this function g. Keep using divisions. Let's call this function g. keep finding zeros and using divisions to reduce it. Let me call this function g. And then we copy function g over. G of s is s cubed minus 7s squared plus 16x minus 12. We know that 2 is a zero of function f. 2 may also be a zero of function g. Let's test 2 again. If I plug 2 into function g, I get 2 cubed minus 7 times 2 squared plus 16 times 2 minus 12. 2 cubed is 8. 2 squared is 4. 4 times 7 is 28. 16 times 2 is 32 minus 12. Adding up, a minus 28 is negative 20. Negative 20 plus 32 is 12. 12 minus 12 is 0. G of 2 equals 0 means 2 is a zero of function g. Then by factor theorem, that means x minus 2 is a factor of function g. By factor theorem, s minus 2 is a factor of function g. Which means if I take function g divided by s minus 2, if I take function g divided by s minus 2, there's no remainder. There's no remainder. So let's divide using syntactic division. I first of all put the coefficient of function g in the first row. I get 1, negative 7, 16, negative 12. For s minus 2, if I put it in the form of s minus c, c is 2, so divide by 2. First of all, bring 1 down. 2 times 1 is 2. Negative 7 plus 2 is negative 5. 2 times negative 5 is negative 10. 16 plus negative 10 is 6. 2 times 6 is 12. There's no remainder. Negative 12 plus 12 is 0. There's no remainder. So that's a divisor. That's a quotient. Next, let me write the quotient back as a polynomial. 6 is the coefficient of 1. Negative 4 is coefficient of x. 1 is coefficient of s squared. Then multiply. I get s squared minus 4x plus 6. If I multiply, 6 times 1 is 6. That's the quotient. That's a divisor. That means g of x equal to s minus 2 times the quotient, s squared minus 4x plus 6. And we know that function f is s minus 2 times g of x. So function f is x minus 2 times g of x. And g of x is s minus 2 times this. This is a quadratic function. We can fit this function using AC method. Can we find two numbers that multiply to be 6, add to be negative 5? One possibility is negative 2 and negative 3. Negative 2 times negative 3 is positive 6. And negative 2 plus negative 3 is negative 5. So f of x is s minus 2 times s minus 2 times s minus 2 times s minus 3. Here we can see that these three factors are exactly the same. So like f of x equal to x minus 2 cubed times x minus 3. Here we factor function f completely. Next, find all zeros. So I set function f equal to 0, which means I set each factor equal to 0. I set s minus 2 cubed equal to 0, set s minus 3 equal to 0. Solve each equation individually. For the first equation, I can take cube root on both sides. I get s minus 2 equal to 0. Then add 2 to both sides. I get s equal to 2. For the second equation, I can directly add 3 to both sides. Add 3 to both sides, I get s equal to 3. So there are 2 zeros. S equal to 2, S equal to 3. So the zeros is 2 and 3. Part D. F of x is 3x to the power 4 plus 5x cubed minus 15x squared minus 11x minus 6. We try to factor function f completely and find all zeros. First step, let's find the potential rational zeros first. Let's find all potential rational zeros first. First of all, let's find p and q. P is a factor of the constant term. Here, constant term is -6. Let's only consider positive 6. Because the factor of 6 and -6 is exactly the same. The factor of 6 and -6 is exactly the same. 6 can be written as 1 times 6 or 2 times 3. Those are the only possibilities. So P could be either plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. Q is a factor of leading coefficient. Here, leading coefficient is 3. 3 can be written as 1 times 3. That's the only possibilities. So the factor of Q is, factor of 3 is plus or minus 1 or plus or minus 3. Those are the only possibility of Q. Then for all potential rational zeros, we use P divided by Q. For all potential rational zeros, take P divided by Q. 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 6 divided by 1 is 6. Continue. 1 divided by 3 is 1/3. 2 divided by 3 is 2/3. 3 divided by 3 is 1. We have 1 already, so don't repeat, cross it out. 6 divided by 3 is 2. But we have 2 already. Don't repeat, cross it out. So those are all potential zeros. That means all rational zeros of function f must be in this form. But which one is a real zero? Let's test it. Let's test 1 first. For f of 1, we plug in 1 for x. We get 3 times 1 to the power 4. 5 times 1 to the power 3. Minus 15 times 1 squared. Minus 11 times 1. Minus 6. Multiply, adding up. 1 to the power 4 is 1. 3 times 1 is 3. 1 cube is 1. And 1 times 5 is 5. 1 squared is 1. 1 times 15 is 15. 11 times 1 is 11. Minus 6. Then adding up. 3 plus 5 is 8. 8 minus 15 is -7. -7 minus 11 is -18. -18 minus 6 is -24. Which is not 0. That means 1 is not 0 of function f. That means 1 is not 0 of function f. Next, let's test for -1. If I plug in -1 for x, I get 3 times -1 to the power 4 plus 5 times -1 cube minus 15 times -1 squared minus 11 times -1 minus 6. Then multiply. -1 to the power 4 is 1. 1 times 3 is 3. -1 cube is -1. -1 times 5 is -5. -1 squared is 1. 1 times 15 is 15. -1 times -11 is positive 11. Minus 6. And then adding up. 3 minus 4 is -2. -2 minus 15 is -17. -17 plus 11 is -6. -6 minus 6 is -12, which is not 0. That means -1 is not zero of function f. Next, let's test for 2. For f of 2, I plug in 2 for x, which is 3 times 2 to the power 4 plus 5 times 2 cube minus 15 times 2 square minus 11 times 2 minus 6. 2 to the power 4 is 16. 16 times 3 is 48. 2 cube is 8. 8 times 5 is 40. 2 square is 4. 4 times 15 is 60. 11 times 2 is 22. Minus 6. And then adding up. 48 plus 40 is 88. 88 take away 60 is 28. 28 take away 22 is 6. 6 take away 6 is 0. If f of 2 is 0, that means 2 is a 0 of function f. So 2 is 0 of function f. Then by factor theorem, if 2 is a 0 of function f, then s minus 2 is a factor of function f. S minus 2 is a factor of function f, which means if I take function f, divide by s minus 2, there's no remainder. So let's divide using long division, using syntactic division. First of all, put the coefficient of function f in the first row. I get 3, 5, negative 15, negative 11, negative 6. 2 here. For s minus 2, if I put it in the form of s minus c, c is 2. Then let's use syntactic division. First of all, bring 3 down. 2 times 3 is 6. 5 plus 6 is 11. 2 times 11 is 22. Negative 15 plus 22 is 7. 2 times 7 is 14. Negative 11 plus 14 is 3. 2 times 3 is 6. Negative 6 plus 6 is 0. There's no remainder. So that's a divisor. That's the quotient. Next, let me know the quotient as a polynomial. 3 is a factor of, is a coefficient of 1. 7 is coefficient of x. 11 is coefficient of s squared. 3 is coefficient of s cubed. Then multiply. The quotient is 3s cubed plus 11s squared plus 7x plus 3 times 1 is 3. That's the quotient, which means f of x equal to x minus 2 times the quotient is 3s cubed plus 11s squared plus 7x plus 3. Since this is a third degree polynomial, it's not easy to factor this directly. So let's call this function g and keep using divisions. Let's call this function g and keep finding 0 and doing divisions. Let's call this function g. Let me copy function g over. G of x is 3s cubed plus 11s squared plus 7x plus 3. Since 2 is a 0 of function f, 2 may also be a 0 of function g. Let's keep testing 2. If I plug in 2, I get 3 times 2 cubed plus 11 times 2 squared plus 7 times 2 plus 3. We know that 2 cubed is 8. 8 times 3 is 24. 2 squared is 4. 4 times 11 is 44. 7 times 2 is 14 plus 3. Then adding up. 22 plus 44 is 68. 68 plus 14 is 82. 82 plus 3 is 85. which is not 0. That means negative 2 is not 0 function g. Next, let's test for negative 2. Since 2 doesn't work, let's test for negative 2. If I plug in negative 2 for x, I get 3 times negative 2 cube plus 11 times negative 2 square plus 7 times negative 2 plus 3. Then multiply. Negative 2 cube is negative 8. Negative 8 times 3 is negative 24. Negative 2 square is 4. 4 times 11 is 44. 7 times negative 2 is negative 14. Then plus 3. Adding up. Negative 22, negative 24 plus 44 is 20. 20 take away 14 is 6. 6 plus 9. 6 plus 3 is 9, which is not 0. That means negative 2 is not 0 function g. Since 1 doesn't work, 2 doesn't work, next let's try 3. For g of 3, we plug in 3 for x. I get 3 times 3 cube plus 11 times 3 square plus 7 times 3 plus 3. 3 cube is 27. 27 times 3 is 81. 3 square is 9. 9 times 11 is 99. 7 times 3 is 21 plus 3. 81 plus 99 is 180. 180 plus 21 is 201. 201 plus 3 is 204, which is not 0. That means 3 is not 0 function g. Next, let's try negative 3. If I plug in negative 3 for x, I get 3 times negative 3 cube plus 11 times negative 3 square plus 7 times negative 3 plus 3. Negative 3 cube is negative 27. Negative 27 times 3 is negative 81. Negative 3 square is 9. 9 times 11 is 99. 7 times 3 is 21. It's negative 21. 7 times negative 3 is negative 21. Plus 3. Negative 81 plus 99 is 18. 18 minus 21 is negative 3. Negative 3 plus 3 is 0. If g of negative 3 is 0, that means negative 3 is a 0 function g. Then by vector theorem, if negative 3 is a 0 function g, that means x minus negative 3. That means x minus negative 3 is a vector of function g. X minus negative 3 is the same as x plus 3. It's a vector of function g. That means if I take function g divided by x plus 3, that's only remainder. So let's divide. Let's use long division and divide. First of all, put the coefficient of function g in the first row. I get 3, 11, 7, and 3 divided by x plus 3. If I write x plus 3 in the form of x minus c, c is negative 3. Then do division, divide by negative 3. I first of all bring 3 down. Negative 3 times 3 is negative 9. 11 plus negative 9 is 2. Negative 3 times 2 is negative 6. 7 plus negative 6 is 1. Negative 3 times 1 is negative 3. And negative 3 plus negative 3 is 0. There's only remainder. That's the quotient. Next, let me run the quotient back as a polynomial. 1 is the coefficient of 1. 2 is the coefficient of x. 3 is the coefficient of s squared. Then let's multiply. I get 3s squared plus 2 plus 1 times 1 is 1. That's the quotient, which means function g equal to x plus 3 times 3s squared plus 2x plus 1. And for function f, we know that function f is x minus 2 times function g. So for function f, we have s minus 2 times function g. Function g is x plus 3 times this. So we get x plus 3 times 3x squared plus 2x plus 1. Now this is a quadratic function. We can factor this using AC method. So factor this using AC method. If I take a times c, I get positive 3. Can we find two numbers that they multiply to be 3 and add to be 2? Can we find two numbers that they multiply to be 3 and add to be 2? It seems impossible. If it's impossible, that means this is not factorable. So leave it the way it is. So here we factor f completely. Next, find all zeros. In order to find all zeros, we set function f equal to 0. Then set each factor equal to 0 and solve for x individually. I first of all set s minus 2 equal to 0, x plus 3 equal to 0, and 3x squared plus 2x plus 1 equal to 0. Solve each function individually. If I solve the first equation, I can add 2 to both sides. I get s equal to 2. If I solve the second equation, I can subtract 3 from both sides. I get s equal to negative 3. For the third equation, since it's not factorable, let me solve it using the quadratic formula. Here, a equal to 3, b equal to 2, and c equal to 1. Let's solve the equation using quadratic formula. Quadratic formula is s equal to minus b plus or minus b squared minus 4ac all over 2a. Let's plug in. A is 3, b is 2, c is 1. Let's plug in. I get minus 2 plus or minus 2 squared minus 4 times 3 times 1 all over 2 times 3. Then simplify. I get negative 2 plus or minus 2 squared is 4. 4 times 3 is 12. 12 times 1 is 12. I get 4 minus 12. On the bottom, 2 times 3 is 6. So here I get negative 2 plus or minus 4 minus 12 is negative a over 6. Next, let's simplify square root of negative a. Square root of negative a can be written as square root of a times square root of negative 1. And square root of a can be written as square root of 4 times square root of 2. Square root of 4 is 2. Square root of 2 stays the same. Square root of negative 1 is I. So square root of negative a is 2 square root of 2 times I. So s equal to negative 2 plus or minus 2 square root of 2 times I divided by 6. Next, let's take both of them divided by 6. Negative 2 divided by 6. I can divide top and bottom by 2, write it as negative 1/3. 2 divided by 6 is 1/3. Plus or minus 2 radical 2 divided by 6. I can again divide top and bottom by 2. I get radical 2 over 3 times I. That means s equal to negative 1/3 plus radical 2 over 3i. Or s equal to negative 1/3 minus radical 2 over 3 times I. So there are 2 zeros here, another 2 zeros here. Together we have 4 zeros. We have 4 zeros. 2, negative 3, negative 1/3, plus radical 2 over 3i, and negative 1/3 minus radical 2 over 3i. So function f has 4 zeros. Function f has 4 zeros. Number 7. Find the polynomials which have the given zeros with only integer coefficients. Part A. The given zeros are -1, 2, and -3. We try to find a polynomial that has these 3 zeros. If a polynomial has these 3 zeros, that means if I set a polynomial to 0, I must get s equal to -1, s equal to 2, and s equal to -3. For each equation, I can move the number to the left side and make it equal to 0. In the first equation, if I move -1 over, I get s plus 1 equal to 0. In the second equation, if I move 2 over, I get x minus 2 equal to 0. On the third equation, if I move -3 over, I get x plus 3 equal to 0. When I move the number over, I change the sign. So -1 become +1, +2 become -2, -3 become +3, which means I have x plus 1 times s minus 2 times x plus 3 equals 0. If s plus 1 is 0, s minus 2 is 0, s plus 3 is 0, that means if I multiply them together, I must also get 0. So this is function f. So function f is s plus 1 times s minus 2 times x plus 3. This is function f. Next, multiply out. Let's multiply function f out. Let me first of all multiply the first 2 polynomials. I get s squared minus 2x plus 1x minus 2. Combine like terms. I get s squared minus 1x minus 2 times x plus 3. Next, let's multiply. S squared times x is s cubed. S squared times 3 is 3s squared. -1x times x is -1s squared. -1x times 3 is -3x. -2 times x is -2x. -2 times 3 is -6. Then combine like terms. I get s cubed. 3s squared minus 1s squared is 2s squared. -3x minus 2x is -5x minus 6. This is function f. That's a function that has zeros, -1, 2, and -3. Part B. Find a polynomial that has zeros. 3, -1/2, and 3/2. These 3 numbers, they are zeros. That means if I set function f equal to 0, I must get s equal to 3, s equal to -1/2, and s equal to 3/2. In the first equation, if I move 3 over, I get x minus 3 equal to 0. In the second equation, since we only want integer coefficients, that means we don't want fractions, I can first of all multiply both sides by 2. If I multiply both sides by 2, I get 2s equal to -1. Then I can move -1 over. I get 2x plus 1 equal to 0. In the third equation, since I don't want fractions, I can multiply both sides by 2. I get 2x equal to 3. Next, I can move 3 over. I get 2x minus 3 equal to 0. If x minus 3 is 0, 2x plus 1 is 0, 2x minus 3 is 0. That means if I multiply all 3 functions together, I must get 0. So I get x minus 3 times 2x plus 1 times 2x minus 3 equals 0. This is function f. This is function f. So f of x is x minus 3 times 2x plus 1 times 2x minus 3 This is function f. Next, let's multiply. Since these two factors, they look more complicated. These two factors look more complicated. Let's multiply these two factors first. So I leave x minus 3 the same. Multiply these two factors first. I get 4x squared minus 6x plus 2x minus 3. Then combine like terms. Combine like terms. I get 4x squared minus 4x minus 3. Then distribute. I get 4x cubed minus 4x squared minus 3x minus 12x squared plus 12x plus 9. And then combine like terms. I get 4x cubed negative 4x squared minus 12x squared is negative 16x squared. Negative 3x plus 12x is 9x plus 9. This is function f. That's the polynomial that has these 3 zeros. That's a polynomial which has these 3 zeros. Part C. Find a polynomial that has zeros 4 and 2i. If 4 and 2i they are zeros, that means if I set function f equal to 0, I must have s equal to 4 and s equal to 2i. Now, since we only want integer coefficients, if 2i is a solution, its conjugate must also be a solution. Since we only want integer solutions, if 2i is a solution, then its conjugate, negative 2i, must also be a solution. Now, try to make 0 on the right side. For each equation, try to make 0 on the right side. In the first equation, if I move 4 over, I get x minus 4 equal to 0. In the second equation, if I move 2i over, I get s minus 2i equal to 0. In the third equation, if I move negative 2i over, I get positive 2i, s plus 2i equal to 0. So, if a complex number is a 0, with integer coefficients, its conjugate is also a solution. So if 2i is a solution, its conjugate, negative 2i, is also a solution. Next, let's multiply. We get s minus 4 times x minus 2i times x plus 2i equal to 0. If x minus 4 is 0, s minus 2i is 0, s plus 2i is 0, then when I multiply, their product must also be 0. So that's function f. F of s equal to s minus 4 times s minus 2i times s plus 2i. Let's multiply. These two factors looks more complicated. It contains I. So let's multiply these two factors first. Distribute, I get s squared plus 2i times x minus 2i times x minus 4i squared. Here, 2i times x cancels negative 2i times x. So what's left here is s minus 4 times s squared minus 4i squared. Here, I squared is negative 1. Negative 1 times negative 4 is positive 4. Next, let's multiply out. X times s squared is s cubed plus 4x minus 4s squared minus 16. Next, write in descending order. We have s cubed minus 4s squared plus 4x minus 16. That's function f. Part D. Find a polynomial that has zeros. Negative 2/3, 1, and negative 3i. If a polynomial has these 3 zeros, that means if I set a polynomial equal to 0, I have s equal to negative 2 over 3, s equal to 1 and s equal to negative 3i. Since we only want integer coefficients, if a complex number is a solution, then its conjugate must also be a solution. Next, try to make the right side equal to 0. For each equation, try to make the right side equal to 0. For the first equation, since we only want integers as coefficient, I multiply both sides by 3. I don't want fractions. I multiply both sides by 3. I get 3x equal to negative 2. Next, move negative 2 over. Move negative 2 over. I get 3x plus 2 equal to 0. For the second equation, I can move 1 over. I get x minus 1 equal to 0. For the third equation, move negative 3i over. I get s plus 3i equal to 0. For the fourth equation, move 3i over. I get s minus 3i equal to 0. If 3x plus 2 is 0, s minus 1 is 0, x plus 3i is 0, and s minus 3i is 0, that means their product must also be 0. So if I multiply 3x plus 2 times s minus 1 times x plus 3i times s minus 3i, it must also be 0. This is function f. This is function f. Function f is 3x plus 2 times s minus 1 times x plus 3i times s minus 3i. Let's multiply the first two terms and last two terms individually. For the first two terms, I get 3x squared minus 3x plus 2x minus 2. For the last two terms, I have s squared minus 3i times x plus 3i times x minus 9i squared. Here we can see that negative 3ix and positive 3ix can cancel. Now combine like terms. What's left is 3x squared minus x minus 2. For the second half, we have s squared minus 9i squared. I squared is negative 1. Negative 1 times negative 9 is positive 9. Next, let's distribute. We get 3x to the power 4 plus 27 s squared minus s cubed minus 9x minus 2s squared minus 18. Then combine like terms. We get 3s power 4 minus s cubed 27s squared minus 2s squared is 25s squared minus 9x minus 18. That's function f. Number A. Perform the indicated operations. Part A. S squared plus 5x plus 6 over s squared minus 5x plus 4 times s cubed minus x over s squared plus 3x plus 2. In order to multiply two rational expressions, let's first of all factor each numerator and denominator. For the first numerator here, s squared plus 5x plus 6, it can be factored using the AC method. First of all, 2x on the parentheses. Then try to find two numbers that they multiply to be 6 and add to be 5. Here we can try positive 2 and positive 3. When we multiply, we get positive 6. When we add, we get positive 5. Now on the denominator, if we factor, we can also use an AC method. Try to find two numbers that they multiply to be 4 and add to be negative 5. We can try negative 1 and negative 4. When we multiply, we get positive 4. When we add, we get negative 5. Next, on the second fraction, if we factor numerator for s cubed minus s squared, for x cubed minus x on the numerator. If we factor, we can first of all pull out x. If we pull out x, what's left is s squared minus 1. S squared minus 1, that's the difference of perfect square. S squared minus 1, that's the difference of two perfect squares. S squared is a perfect square, 1 is also a perfect square. So using the formula, difference of perfect squares, we have x plus 1 times s minus 1. That's the numerator. I get x times s plus 1 times x minus 1. On the denominator, if we factor, we can use AC method here. Try to find two numbers that they multiply to be 2 and add to be 3. We can try positive 1 and positive 2. When we multiply, we get positive 2. When we add, we get positive 3. Next, try to cancel the common factors on the top and the bottom. Here, x plus 2 and x plus 2, they look exactly the same. I can cancel s plus 2 from top and bottom. Next, s minus 1 on the top and the bottom looks exactly the same. I can cancel s minus 1 from top and the bottom. And also, s plus 1 looks exactly the same on the top and the bottom. I can cancel s plus 1. What's left on the top is x plus 3 and x. Since x is outside parentheses, write x in the front. I get x times x plus 3. That's the numerator. On the denominator, we have x minus 4. That's the final answer to part A. Part B, we have x to the power 4 minus 16 over s squared plus 2x minus 8 divided by x to the power 4 minus 5x squared minus 36 over s squared plus 7x plus 12. When we have division, we first of all keep the first fraction the same. Change division to multiplication, and then flip the second fraction over. When we have a fraction divided by another fraction, we keep the first fraction the same. Change division to multiplication, and then flip the second fraction over. So I get s to the power 4 minus 16 over s squared plus 2x minus 8 times s squared plus 7x plus 12 over x to the power 4 minus 5x squared minus 36. Now try to factor each numerator and denominator individually. Try to factor each numerator and denominators individually. First numerator here. X to the power 4 minus 16. That's the difference of perfect squares. X to the power 4 is s squared squared. 16 can be written as 4 squared. So we have s squared plus 4 times s squared minus 4. Then here, s squared plus 4 is not factorable. We leave it the way it is. But for s squared minus 4, that's another difference of perfect squares. S squared is a perfect square. Number 4 is 2 squared. So if we factor, we get s plus 2 times s minus 2. That's how we factor the first numerator. I get s squared plus 4 times s plus 2 times s minus 2. That's the first numerator. And for the first denominator, there are 3 terms. We can use AC method. Try to find two numbers that they multiply to be negative a and add to be positive 2. Try to find two numbers that they multiply to be negative a and add to be positive 2. We can try plus 4 minus 2. When we multiply, we get negative a. When we add, we get positive 2. Now for the second numerator, we have s squared plus 7x plus 12. We can also use an AC method. Put x on the parentheses and try to find two numbers that they multiply to be 12, add to be 7. The only possibility is 3 and 4. When we multiply, we get 12. When we add, we get 7. Now for the denominator here, we have s to the power 4 minus 5s squared minus 36. We can first of all apply an AC method. when there are 3 terms, we can first of all apply the AC method. S to the power 4 can be split as s squared times s squared. Next, try to find 2 numbers that they multiply to be negative 36 and add to be negative 9. One possibility is positive 4 and negative 9. When we multiply, we get negative 36. When we add, we get negative 5. Then s squared plus 4, that's not factorable. We need to know what it is. But for s squared minus 9, that's the difference of perfect squares. S squared is a perfect square. 9 is 3 squared. So factor using difference of perfect square. Use difference of perfect square. We have x plus 3 times x minus 3. That's the denominator. We have x squared plus 4 times x plus 3 times x minus 3. After factoring, cancel common factors from top and bottom. I can first of all cancel s squared plus 4 from top and bottom. I can cancel s minus 2 from top and bottom. I can cancel s plus 3 from top and bottom. And also I can cancel x plus 4 from top and bottom. What's left is x plus 2 on the numerator and x minus 3 on the denominator. That's the final answer to part B. Part C, we have x over s squared plus 3x plus 2 plus 12 over s squared minus 2x minus a. In order to add or subtract rational expressions, we need to first of all find the least common denominator. In order to find the least common denominator, we must factor each denominator first. First denominator can be factored using AC method. We try to find 2 numbers that they multiply to be 2, add to be 3. The only possibility is positive 1 and positive 2. That's the first denominator. For the second denominator, we can also factor using the AC method. Find 2 numbers that they multiply to be negative a and add to be negative 2. One possibility is negative 4 and positive 2. That's the denominator. Next, based on denominator here, we try to find the least common denominator. The least common denominator must include all factors on both denominators. So we need to have s plus 1, s plus 2, and s minus 4. We have s plus 2 already. Don't repeat, only write it once. So that's the least common denominator. Next, try to rewrite every fraction over the least common denominator. Try to rewrite every fraction over the least common denominator. The first fraction is x over s plus 1 times s plus 2. If we compare this denominator with an LCD, we can see that what's missing is s minus 4. If we compare this denominator with LCD, we can see that what's missing is s minus 4. So times s minus 4 to the top and the bottom. If I multiply s minus 4 to the top and the bottom, the denominator will look exactly the same as an LCD. For the second fraction, what we have is 12 over s minus 4 times s plus 2. If we compare the denominator with an LCD, we can see that what's missing is s plus 1. So we multiply s plus 1 to both the top and the bottom. If we multiply s plus 1 to both top and the bottom, the denominator will look exactly the same as an LCD. Now, since the denominator is the same, we only write it once. Write the common denominator only once. S plus 1, s plus 2 times s minus 2 times s minus 4. Then put the numerator together. We have x times s minus 4 plus 12 times s plus 1. Then simplify the numerator. If I distribute x, I get s squared minus 4x. If I distribute 12, I get 12x plus 12. over s plus 1 times s plus 2 times s minus 4. Then on the numerator, we combine like terms. On the numerator, we combine like terms. Negative 4x plus 12x is positive ax. Keep the button the same. S plus 1, s plus 2 times s minus 4. Next, we try to factor the numerator. The numerator here can be factored as x plus 2 times x plus 6. Here we use AC method. Find two numbers, then they multiply to be 12, and add to be a. The denominator is s plus 1 times s plus 2 times s minus 4. Now we can see that here, s plus 2 is the same on the top and the bottom, so we can cancel the common denominator on the top and the bottom. The final answer is x plus 6 over s plus 1 times s minus 4. Let's answer to part C. Part D. We have x over x minus 3 minus 2 over s minus 4 plus 2 over s squared minus 7x plus 12. In order to add or subtract rational expressions, let's first of all find least common denominator. In order to find the least common denominator, we need to factor each denominator first. The first denominator is not factorable, so I leave it the way it is. The second denominator is also not factorable, I leave it the way it is. The third denominator can be factored using the AC method. If I factor using the AC method, I get x on each parentheses, and then find two numbers, then they multiply to be 12, and add to be negative 7. The only possibility is negative 3 and negative 4. Now, for the least common denominator, it must include all factors on the denominator. So we have x minus 3, x minus 4. We have s minus 3 already, so only write it once. We have s minus 4 already, only write it once. So that's the least common denominator. Next, try to write every denominator over the LCD, over the least common denominator. The first term is x over x minus 3. If we compare the denominator of LCD, we can see that what's missing is s plus 4. What's missing is s minus 4. So multiply s minus 4 to both the top and the bottom. Then the denominator will look exactly the same as an LCD. For the second term, do the same thing. If we compare the denominator with an LCD, we can see that what's missing is s minus 3. So times x minus 3 to the top and the bottom at the same time. After we multiply, we can see that the denominator x minus 3, x minus 4 looks exactly the same as LCD. For the third fraction, we have 2 over x minus 3 times s minus 4. This denominator is exactly the same as LCD, so leave it the same, don't make any change. This denominator looks exactly the same as LCD, so leave it the same, don't make any change. Now, here, once we make all denominators exactly the same, combine everything together, we only write the denominator once, x minus 3 times s minus 4. If all denominators look exactly the same, only write it once, only write the common denominator once, then put all numerators together. We have x times s minus 4 minus 2 times x minus 3 plus 2. Next, simplify the numerator. If I distribute x, I get s squared minus 4x. If I distribute negative 2, I get negative 2x plus 6 and then plus 2. Leave the denominator the same. I get x minus 3 times s minus 4. Then on the numerator, we combine like terms. If we combine like terms, we get s squared minus 6x plus a over x minus 3 times s minus 4. Next, we can try to factor the denominator. We can try to factor the numerator. If we factor the numerator, we can use AC method. Find two numbers, then they multiply to be a and add to be -6. The only possibility is -2 and -4. When we multiply, we get positive a. When we add, we get -6. That's the numerator. And we leave the denominator the same. X minus 3 times s minus 4. Here we can see that s minus 4 looks exactly the same on the top and the bottom. So I can cancel the common factors on the top and the bottom. What's left is x minus 2 over x minus 3. That's the final answer to part D. Number 9. Graph each of the following functions. Please indicate the x and y intercepts, horizontal and vertical asymptotes if it exists, and describe the end behaviors. Part A. f of x is x plus 2 times x minus 3 squared times s plus 5. In order to graph a polynomial function, let's first of all find the zeros. In order to find the zeros, we set f of x equal to 0. So first step, set f of x equal to 0. Then solve the equation for x. If we set a factored polynomial to 0, that means every factor must be 0. We have s plus 2 equal to 0, x minus 3 squared equal to 0, and s plus 4 equal to 0. Next, solve each equation for x. For the first equation, I can subtract 2 from both sides. I get s equal to -2. For the second equation, I can first of all take square root on both sides. We get s minus 3 equal to 0. And then add 3 to both sides. We get s equal to 3. For the third equation, I can subtract 5 from both sides. I get s equal to -5. So those are zeros of this polynomial function. And here, for -2, since the degree is 1, we say the multiplicity is 1. For -2, its multiplicity is 1. For number 3, since the degree is 2 here, the multiplicity of 3 is 2. For number 5, for -5, since the degree is 1, its multiplicity is 1. Now, for those zeros, if the multiplicity is more than 1, when we sketch the graph, for example, for number 3 here, when we sketch the graph, the curve doesn't go through the 0 directly. There's a little curvature. Either it goes up or it goes down on the other side. There's a little curvature around the 0. Either it continues going up or it turns over. If the degree is more than 1, if the multiplicity is more than 1, the curve doesn't go through the 0 directly. There's a little curvature. And if the multiplicity is 1, for example, at -2, if the multiplicity is 1, the curve goes through the 0 almost straight. If the multiplicity is 1, the curve goes through the 0 almost straight. So that's the difference. When the multiplicity is 1, and that's when the multiplicity is more than 1. And the larger multiplicity, the larger curvature it is in the 0. And we know that those zeros is the same as the S-intercepts. Those zeros is the same as the S-intercepts. So the S-intercepts they are -2, 0, 3, 0, and -5, 0. Those are the S-intercepts. For the y-intercept, we set s equal 0, y equal to f of 0. If I plug in 0 to the function, I get 0 plus 2 times 0 minus 3 squared times 0 plus 5. 0 plus 2 is 2. 0 minus 3 is negative 3. Negative 3 squared is 9. And 0 plus 5 is 5. 2 times 9 is 18. 18 times 5 is 90. So the y-intercept is 0, 90. Now, next, in order to sketch a graph, let's make number line test. First of all, let's label the zeros. -2, 3, and -5. Put numbers in order from left to right. Put in order. We have -5, that's the smallest. Next is -2. The largest is number 3. Three numbers color line into four regions. 3 numbers color number line into 4 regions. Next, let's pick some test number to test for positive or negative for function f. Let's pick some test numbers. On each region, pick test number. Let's first of all pick number less than -5. I can pick -6. Pick number between -5 and -2. I can pick -3. Pick number between -2 and 3. I can pick 0, make it easy. Pick number greater than 3, I can pick 4. Next, plug each test number into function f and test for positive or negative. If I plug in -6 into function f, -6 plus 2 is -4, which is negative. If I plug in -6 in the second term here, -6 plus 3 is -6 minus 3 is -9. -9 squared, double negative is positive. If I plug in -6 here, -6 plus 5 is -1, which is negative. When we multiply or divide, if there are even number of negative signs, the final product is positive. When we multiply or divide, if there are even number of negative signs, the final answer is positive. If there are odd number of negative signs, the final answer is negative. If there are even number of negative signs, the final answer is positive. If there are odd number of negative signs, the final answer is negative. Next, plug in -3. If we plug -3 here, -3 plus 2 is -1. That's negative. -3 minus 3 is -3. It's -6. -6 when we square, double negative become positive. If I plug in -3 here, -3 plus 5 is +2, which is positive. When we multiply, there's only one negative sign. If there are a number of negative signs, the final answer is negative. When we multiply or divide, if there are a number of negative signs, the final answer is negative. Next, plug in 0. 0 plus 2 is positive. 0 minus 3 is -3. -3 when we square, it becomes positive. Plug in 0 here. 0 plus 5 is 5, which is positive. Positive number times positive number times positive number is positive. If every term is positive, if every factor is positive, their product must be positive. Next, plug in 4. If we plug in 4 here, 4 plus 2 is positive, is 6, that's positive. 4 minus 3 is 1, 1 squared is positive. Plug in 4 here, 4 plus 5 is 9, 9 is positive. If all 3 numbers are positive, when we multiply 3 positive numbers, the answer is positive. Next, based on this picture, let's sketch graph. Positive, negative, positive, positive. First of all, label the X-intercepts. First of all, label the X-intercepts. X-intercept here is -2, 3, -5. -2, 3, -5. One, 2, 3. That's X-intercept. -2. That's another X-intercept. -5. That's another X-intercept. And we know that the sign here is positive, negative, positive, positive. Positive, negative, positive, negative. If function f is positive, that means it goes above x-axis. If function f is positive, that means it goes above x-axis. In this region, if function f is negative, that means it goes below x-axis. Now, at -2 here, at -5, -2, the multiplicity is 1. At -2, -5, multiplicity is 1. So the curve goes through the 0, almost straight. The curvature is very, very small. But at 3 here, multiplicity is more than 1. That means when the curve touches this point, there's a little curvature. It doesn't go through the point directly. There's curvature at this point. Now, between -2 and -5 and -2, f is negative. That means it goes below the x-axis. It goes below the x-axis. Between -2 and 3, function f is positive. That means it goes above the x-axis. Now here, at 3, since the multiplicity is 2, the curve doesn't go through the point directly. There's a little curvature here. Last region is also positive, which means function f go above x-axis. That means function f go above the x-axis. Since multiplicity is 2, there's a little curvature here. And also we know that the x-intercept here, x-intercept is -2, 3, and -5. X-intercept is -2, 3, and 5. Y-intercept is 0, 90. So this point is 90. Since this is a very rough sketch, we didn't draw the y-axis in scale. So just label this point to be 90. Because we didn't draw the y-axis in scale. This is a rough sketch. This is a very rough sketch. We didn't draw the y-axis in scale. So this point is 90. That's the y-intercept. Then the end behavior. The x-intercept is -5, 0, -2, 0, 3, 0. The y-intercept is 0, 90. Next, let's describe the end behavior. For the end behaviors, there are 2 ends. This graph has 2 ends, the left end and right end. So for the left end, as x approaches to -infinity, for the left end, as x approaches to -infinity, function f goes all the way up. That means f of x approaches to infinity. On the right end, as s approaches to infinity, function f also goes all the way up, which means f of x approaching infinity. And the line m, function f also goes all the way up, so f of x approaches to infinity. That's the m behaviors. Part B, f of x is 2x minus 1 squared over s minus 4 times 2x plus 3. In order to graph a rational function, let's first of all find the horizontal and vertical asymptotes. For the horizontal asymptote, let's first of all compare the degree on the top and the bottom. If the top degree is larger, then there's no horizontal asymptote. If the bottom degree is larger, the horizontal asymptote is always y equal to 0. But if the top degree and the bottom degree are the same, the horizontal asymptote is always y equal to the ratio of the leading coefficient on the top and the bottom. So, in order to find the horizontal asymptote, let's find the leading term on the top and the bottom first. For leading term on the top and the bottom, for 2x minus 1, the leading term is 2x. And we have square here. On the bottom, for x minus 4, the leading term is x. For 2x plus 3, leading term is 2x. If we multiply, on the top we get 4x squared. On the bottom we get 2x squared. So here we can see that both top and bottom has degree 2. X squared. Both top and bottom has degree 2. Both top and bottom has degree 2. If the top degree is the same as the bottom degree, then the horizontal asymptote is always y equal to the ratio of the leading coefficients. Ratio of leading coefficient is 4 over 2. 4 is called leading coefficient of the top. 2 is called leading coefficient of the bottom. 4 over 2, that's the ratio of the leading coefficients on the top and the bottom. If we simplify, we get 2. So the horizontal asymptote is y equal to 2. That's the horizontal asymptote. Next, for the vertical asymptote, we set the denominator equal to 0. For the vertical asymptote, we set the denominator equal to 0. Solve the equation for x. If the product of two factors equals 0, we set each factor equal to 0. If the product of two factors is 0, we set each factor equal to 0. Then solve each equation individually. If I solve the first equation, I can add 4 to both sides. I get s equal to 4. If I solve the second equation, I can subtract 3 from both sides. Then divide both sides by 2, s equal to negative 3 over 2. Now make sure this number doesn't make the top to be 0. If this number doesn't make the top to be 0, it's a vertical asymptote. But if this number makes the top to be 0, it doesn't count as a vertical asymptote. So if I plug in 4 to the top, 2 times 4 is 8. 8 minus 1 is 7. 7 squared is not 0. So that's a vertical asymptote. If I plug in negative 3 over 2, negative 3 over 2 times 2 is negative 3. Negative 3 minus 1 is negative 4. Negative 4 squared is 16, which is not 0. So this also counts. So there are two vertical asymptotes. That's a horizontal asymptote, that's a vertical asymptote. Next, let's find the zeros. Let's find the zeros for function f. For a rational function, if we try to find 0, we set the numerator equal to 0. So for the zeros, we set the numerator equal to 0. When the numerator is 0, the entire fraction is 0. So for rational function, we only set the numerator equal to 0. In order to find 0, for rational function, we only set the numerator equal to 0. So set 2x minus 1 squared equal to 0. If I take square root on both sides, I get 2s minus 1 equal to 0. Then I can add 1 to both sides. I get 2s equal to 1. Then I can divide both sides by 2. I get s equal to a half. That's a 0. And the 0 is the same as s-intercept. The 0 is the same as s-intercept. S-intercept is half, comma 0. The 0 is the same as s-intercept. So s-intercept here is half, comma 0. And for rational function, we don't care about the multiplicity. Here, multiplicity is 2. But for rational functions, we don't really care about the multiplicity. Only for polynomial functions, we have to find the multiplicity. For rational functions, we don't really care about the multiplicity. That's the s-intercept. For the y-intercept, we set s equal to 0. If I plug in 0 for x, y is f of 0, which is 2 times 0 minus 1 square over 0 minus 4 times 2 times 0 plus 3. Then calculate this. On the numerator, 2 times 0 is 0. 0 minus 1 is negative 1. So I get negative 1 square. On the bottom, I get 0 minus 4 is negative 4. 2 times 0 is 0. 0 plus 3 is 3. On the numerator, negative 1 square is 1. On the denominator, negative 4 times 3 is negative 12. So the y-intercept is 0, comma, negative 1 over 12. That's the y-intercept. That's an s-intercept, that's a y-intercept. Next, let's make a number line test. Make a number line test. Test for positive or negative of this function. Let me first of all copy function f here. Function f is 2x minus 1 square over s minus 4 times 2x plus 3. Let's make number line test. In the number line, let's label the zeros and the vertical asymptotes. Let's label the zeros and the s-intercepts and the vertical asymptotes. Label the zeros and the vertical asymptotes. Vertical asymptote is 4 and negative 3 over 2. 0 is half. Put these three numbers on the number line and write them in order. Put these numbers in orders. The smallest is negative 3 over 2. Next is a half. The largest is 4. And 4 and negative 3 over 2, they are vertical asymptotes. A half is a 0. If I cut a line 3 times, I make it into 4. I cut it into 4 regions. Next, let's pick test number on each region. Let's test the positive or negative for function f. First of all, pick number less than negative 3 over 2. I can pick negative 2 here. Next, pick number between negative 3 over 2 and a half. I can pick 0. Make it easy. Pick 0. Pick number between these two numbers. Make it easy. I pick 0. Next, pick number between a half and 4. Make it easy. I pick 1. Next, pick number larger than 4. Let me pick 5. Next, plug each test number into function f. Plug each test number into function f. If I plug in negative 2, on the numerator, 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5. Negative 5 squared is positive. On the bottom, if I plug in negative 2 here, negative 2 minus 4 is negative 6. That's negative. If I plug in negative 2 here, 2 times negative 2 is negative 4. Negative 4 plus 3 is negative 1, which is negative. Then multiply and divide. if there are even number of negative signs, if there are even number of negative signs, there are two negative signs here. If there are even number of negative signs, when we multiply or divide, answer is positive. If there are odd number of negative signs, when we multiply or divide, answer is negative. Next, let's plug in 0. If I plug in 0, on the numerator, 2 times 0 is 0. 0 minus 1 is negative 1. Negative 1 squared is positive 1, which is positive. Next, plug in 0 to denominator. If I plug 0 here, 0 minus 4 is negative 4, which is negative. If I put 0 here, 2 times 0 is 0. 0 plus 3 is negative. 0 plus 3 is positive 3. That's positive. Next, let's multiply and divide. In general, if there are a number of negative signs, answer is negative. If there are even number of negative signs, answer is positive. If there are a number of negative signs, answer is negative. Next, plug in 1. On the numerator, 2 times 1 is 2, and 2 minus 1 is 1. 1 squared is 1, which is positive. Plug 1 to the denominator. 1 minus 4 is negative 3, which is negative. Put 1 here. 2 times 1 is 2. 2 plus 3 is 5, which is positive. Then multiply and divide. There's only one negative sign. If there are a number of negative signs, when we multiply or divide, answer is negative. Next, plug in 5. If I plug in 5, 2 times 5 is 10. 10 take away 1 is 9. 9 squared is positive. Put 4 in the denominator. 5 minus 4 is 1, which is positive. Put 5 here. 2 times 5 is 10. 10 plus 3 is positive. Then multiply and divide. When we multiply or divide all positive numbers, answer is positive. Now, that's a number line test. Next, for rational function, we must test for horizontal asymptote, the end behavior of a horizontal asymptote. So next, let's test for horizontal asymptote. At the left end, we plug in some very, very large negative numbers, say f of negative 100. If we pick negative f of negative 1000, there's nothing wrong. Make it easier, let me take negative 100 here. That's the end behavior of the horizontal asymptote in the left end. Next, on the right end, I plug in 100. That's the end behavior around horizontal asymptote. That's the end behavior around horizontal asymptote. Let's plug in negative 100 and positive 100. Here I use calculator. Put 100 here, the number is very, very large. If I plug in 100 for x, the number is very, very large. Here I use my calculator. If I plug in negative 100, I get 1.972. In my calculator, I get 1.972. For f of 100, if I plug in 100 for x, the number is very, very large. Again, I use my calculator. In my calculator, I get 2.032. That means at the left end, the curve is a little less than 2. At the right end, the curve is a little more than 2. Now, based on this information, let's sketch a graph. Based on this information, let's sketch a graph. When we sketch the graph, let's first of all draw the asymptotes. Let's draw the vertical asymptote, horizontal asymptote, vertical asymptote first. Here, horizontal asymptote is y equal to 2. Horizontal asymptote is y equal to 2. That's the horizontal asymptote. Vertical asymptote is s equal to 4 and s equal to negative 3 over 2. That's a vertical asymptote at 4. Another vertical asymptote is negative 3 over 2. 3 over 2 is 1.5, so that's negative 1.5. It's negative 1, negative 2. Negative 1.5 is somewhere between negative 1 and negative 2. So that's another vertical asymptote. Next, label X and Y intercepts. X-intercept is a half. Y-intercept is 0, negative 1 over 12. X-intercept is here, a half. Y-intercept is 0, negative 1 over 12. Somewhere below the x-axis. Next, let's sketch a graph based on above information. First of all, when x is less than negative 3 over 2, function f is positive. Negative 3 over 2 is here. That means when x is less than negative 3 over 2, function f is positive. Positive means the curve is above x-axis. And the curve must get closer to both vertical and horizontal asymptotes. The curve must get close to both asymptotes. That's the vertical asymptote, that's the horizontal asymptote. The curve must get closer to both asymptotes. So the curve is here. It must get closer to both asymptotes. Now, let's the horizontal asymptote. The curve may directly approach the horizontal asymptote from above. That's one possibility. Or the curve may go through the asymptote first and then approach from below. That's another possibility. The curve may directly approach the horizontal asymptote from above, or it may go through the asymptote first, then approach from below. There are two possibilities. Here we must check a very, very large number, very large negative number, and see what happened. If we plug in a very, very large negative number, we get 1.972. This is a little less than 2. That means the curve will approach the horizontal asymptote from below. So the curve will approach the horizontal asymptote from below. So that's the second case. The curve will eventually go through the asymptote first, then approach from below. Since when I plug in very, very large negative number, it's less than 2. So the curve approaching the horizontal asymptote from below. That's one piece. Second piece. When s is between negative 3 over 2 and half, function f is negative. So between negative 3 over 2 and half, function f is negative. Negative means the function goes below x-axis. If the function is negative, that means the function goes below the x-axis. And the function must get closer to vertical asymptotes. So that's an X-intercept, which is 1 over 2. Y-intercept is negative 1 over 12. Let me label here. That's negative 1 over 12. The curve of polynomial function or rational function is always smooth. It's always smooth. That means there's no sharp angles. There's no corners. There's no sharp angles. Next region. When s is between half and 4, function f is negative, which means function f go below the x-axis. So between half and 4, function f is negative. That means it goes below x-axis. And the function f must get closer to the asymptotes, to the vertical asymptotes. It's a smooth curve, making the curve smooth. Don't use any sharp angles. That's the second piece. That's the third piece. For the last piece, function f is positive. That means the curve is above x-axis. That means the curve is above x-axis. And the curve must get closer to both asymptotes. That's the vertical asymptote, and that's the horizontal asymptote. The curve must get closer to both asymptotes. Since it's positive, it must be here. It must get closer to both asymptotes. Again, there are two possibilities. The curve may approach the horizontal asymptote from above, or it may go through the asymptote, then approach from below. There are two possibilities. The curve may approach the horizontal asymptote from above, or it may go through the asymptote first and then approach from below. There are two possibilities. In this case, we plug in a very, very large positive number. If I plug in 100, a very, very large positive number, I get 2.032. That's above 2. That means the curve will eventually approach the horizontal asymptote from above. So the curve will approach the horizontal asymptote from above. It's the first case. The curve approaches the horizontal asymptote from above. That's the graph of this rational function. That's the graph of this rational function. Next, let's describe the m behaviors. The question is asking for x-intercept, y-intercept, and m behaviors. For an x-intercepts, we have -3/2, 0. X-intercept is 0.5, 0. Sorry. X-intercept is 0.5, 0. Y-intercept is 0, -1/12. For horizontal asymptote, we have y equal to 2. For the vertical asymptote, we have s equal to 4 and s equal to -3/2. Next, let's describe the m behaviors. Let's describe the m behaviors. In the graph, we have 1, 2, 3, 4, 5, 6. There are 6 n's. Let's describe these 6 m behaviors. Let's first of all describe the m behavior on the left and right. On the left side, as x approaches to -infinity, f of x approaches to 2 from below. F of x approaches to 2 from below. This little minus means approach to 2 from below. This little minus sign here means it's below 2. On the right end, As s approaches to infinity, as s approaches to infinity, function f approaches to 2. Function f approaches to 2. It's a little above 2. So f approaches to 2 from above. Little plus means approach from above. The curve is a little above 2. So f of x approaches to 2 from above. Now, let's describe these two ends here. This point here is -3/2. As s approaches to -3/2, from the left, on the left side, as h approaches to 3/2 from the left, f of s goes all the way up. That's the left side, that's the right side. For -3/2 on the left side, function f goes all the way up, which means function f approaches to infinity. As s approaches to -3/2 from the right, as s approaches to -3/2 from the right, that's the left side, that's the right side. On the right side, function f goes all the way down. At -3/2 on the right side, the function goes all the way down, which means f of x approaches to -infinity. Next, let's look at these two ends here. This number here is 4. That's left side, and that's the right side. As s approaches to 4 from the left, as s approaches to 4 from the left, on the left side, the curve goes all the way down. That means function f approaches to -infinity. F of x approaches to -infinity. And on the right side, as s approaches to 4 from the right, as s approaches to 4 from the right, that's the left side, that's the right side, function f goes all the way up. So f of x approaches to infinity. That's the end behavior of the curve. That's the end behavior of the curve. Number 10. Simplify each of the following expressions. Part A. How can we simplify 4 to the power of -3? When the exponent is negative, we first put 1 on top, make it positive. And then we know that 4 to the power of 3 means 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So the answer is 1 over 64. That's the answer to part A. Part B. 2 to the power of 4 times 5 to the power of 0 times 6 to the power of -2. We know that any number to the power of 0 is 1. So that's the same as 2 to the power of 4 times 1. And when we have 6 raised to negative 2, if the exponent is negative, put 1 on top, make exponent positive. And then together we have 2 to the power 4 is 16 times 1 times 1 over 6 squared. 6 squared is 36. Then we multiply 16 times 1 is 16. I get 16 over 1. 16 can be rewritten as 16 over 1 times 1 over 36. Then multiply top to the top, bottom to the bottom. I get 16 over 36. That can be simplified as 4 over 9. I can divide both top and bottom by 4. I get 4 over 9. That's the final answer to part B. Part C. How can we simplify 81 to the power of negative 3 over 4? First of all, when the exponent is negative, put 1 on top, make it positive. Then simplify denominator. 81 to the power of 3 over 4. When we have 81 to the power of 3 over 4, write a root. 4, the denominator is the index. 81 is the base. Exponent, the numerator is exponent, power 3. So, base is 81. The denominator is the index in the front. Numerator is exponent. Then simplify. The 4 root of 81 is 3. 3 to the power of 3 is 27. That's the final answer, 1 over 27. Part D. Simplify negative 32 to the power of 7 over 5. Here, 7 over 5 is the rational exponent. First of all, draw a root. Negative 32 is the base. The denominator 5 is the index in the front. The numerator 7 is the exponent outside. Let's do the parentheses first. Let's first of all compute the fifth root of negative 32, which that's negative 2. The fifth root of negative 32 is negative 2, because negative 2, 5 negative 2 multiplied together is negative 32. So the fifth root of negative 32 is negative 2. Then take negative 2 raised to the power of 7. Let me take 7 negative 2 multiplied together. Answer is negative 128. That's the answer to part B. That's the answer to part D. Part E. We have 2x to the power of negative 3 raised to the power of 4 times 3x to the power of 7. Let's distribute the outer exponent first. If there's exponent outside parentheses, distribute the outer exponent first. We get 2 to the power of 4 times x to the power of negative 12. 4 times negative 3 is negative 12 times 3 times x to the power of 7. Now compute the numbers. 2 to the power of 4 is 16. 16 times 3 is 48. Next, multiply x together. X to the power of negative 7 times x to the power of 7. X to the power of negative 12 times x to the power of 7. Now we multiply two numbers with the same base. Keep the base and exponents. Negative 12 plus 7 is negative 5. Keep the base and exponent. Negative 12 plus 7 is negative 5. For the final answer, if the exponent is negative, bring the denominator, make it positive. For the final answer, if the exponent is negative, bring the denominator, make it positive. So the final answer is 48 over x to the power of 5. That's the final answer to part E. F. We have 2x raised to negative 2, y to the power of 4, or raised to the power of negative 3, over 6x to the power of negative 5, y to the power of negative 3, all raised to the power of -1. So if there's exponent outside the parentheses, let's distribute exponent first. First of all, we get 2 raised to -3 times x to the power of 6. -3 times -2 is +6 times y to the power of -12. -3 times 4 is -12. On the bottom, do the same thing. Let's distribute exponent first. We get 6 raised to -1 times x to the power of 5. -1 times -5 is +5. Y to the power of +3. -1 times -3 is +3. Now next, if an exponent is negative on the top, move to the bottom, make it positive. If exponent is negative on the top, move to the bottom, make it positive. If exponent is negative on the bottom, move to the top, make it positive. So after moving, I have 6 to the power of +4 on the top, x to the power of 6 on the top. On the bottom, we have 2 to the power of 3 on the bottom, x to the power of 5, y to the power of 3. If I move this term down, I get y to the power of 15. Then simplify. I get 6x to the power of 6 on the top. On the bottom, 2 to the power of 3 is 8. X to the power of 5 stays the same. Y to the power of 3 times y to the power of 15. When we multiply two numbers with the same base, keep the base and exponent. 3 plus 15 is 18. When we multiply two numbers with the same base, keep the base and exponent. 3 plus 15 is 18. Now, here we see 6 and 8 can be reduced. For 6 and 8, I can divide both top and bottom by 2. I get 3 on the top, 4 on the bottom. Now, for x here, we have x on the top, x on the bottom. We need to cancel x from top and bottom. Now, observe x. Here we can see that x on the top has larger power. X on the top has larger power. So we keep x on the top. Take larger power minus a smaller power. 6 minus 5 is 1. And then y set on the bottom. So for the final answer, we write 3x over 4y to the power of 18. That's the final answer to F. Part G. How can we simplify? The cube root of 48 times a to the power of 7, b to the power of 14. If there's a number in the front, let's factor this number first. 48 can be factored as 6 times a. 6 can be factored as 2 times 3. And 2 and 3 they cannot be broken down, different way it is. A can be factored as 2 times 4. Number 2 cannot be broken down anymore, but 4 can be broken down as 2 times 2. So look at the end of the branch. We have 2, 3, 2, 2, 2. We have number 2 4 times. Number 3 only once. So 48 equal to 2 to the power of 4 times 3 to the power of 1. So factor 48 first. I get 2 to the power of 4 times 3 to the power of 1 times a to the power of 7 times b to the power of 14. Next, split the roots. We have cube root of 2 to the power of 4 times cube root of 3 to the power of 1 times cube root of 8 to the power of 7 times cube root of b to the power of 14. Simplify each of them individually. First one, 2 to the power of cube root of 2 to the power of 4. If the exponent is more than the index, take 4 divided by 3, take remainder. Take 4 divided by 3, take remainder. 4 divided by 3 is 1. Remainder is 1. 4 divided by 3, quotient is 1. Remainder is 1. So the quotient means exponent outside. I get 2 to the power of 1 outside. The remainder means exponent inside the root, under the root. I get cube root of 2 to the power of 1. So the quotient means exponent outside the root. Remainder means the exponent inside the root. Next, for cube root of 3 to the power of 1, since the exponent is less than the index, I leave it the way it is. Cube root of 3 to the power of 1. Since the exponent is less than the index, I leave it the way it is. So leave it the way it is. Cube root of 3 to the power of 1. Next, cube root of 8 to the power of 7. 7 is more than 3, so let's do long division. 7 divided by 3. 3 goes into 7 twice. 2 times 3 is 6, remainder is 1. So this 2, the quotient 2 is an outside exponent. This 1 is an exponent under the root. So this 2 represents exponent outside the root. This 1 represents exponent under the root. Next, cube root of b to the power of 14. 14 is more than 3, so take 14 divided by 3. 3 goes to 14 4 times. 4 times 3 is 12. Remainder is 2. So power 4, this means exponent outside the root. I get b to the power 4. This 2 represents exponent under the root. This 2 represents exponent under the root. So I get cube root of b to the power of 2. Next, for the final answer, we multiply everything outside the root together. Outside the root we have 2 to the power 1, a to the power 2, b to the power 4. I get 2a squared b to the power 4. That's what's outside the root. Under the root we have 2 times 3 times a times b squared. Under the root, under the cube root, we have 2 times 3 times a times b squared. 2 times 3 is 6. So I get 6ab squared. That's how we simplify an answer for part G. The final answer is 2a squared b to the power 4 times cube root of 6ab squared. H. Simplify. The 4 root of x squared times square root of x times the cube root of x. First of all, let's rewrite these roots in exponential form first. The fourth root is the power of 1 over 4. The fourth root is power of 1 over 4. Then under the root we have x squared times square root of x. Square root of x is x raised to 1 over 2 times cube root of x. Cube root of x is x raised to 1 over 3. Next, let's compute what's under the root, inside the root first. What's inside the root here? We have s squared times s to the half times s to the third. When we multiply numbers with the same base, we keep the base and exponents. 2 plus a half plus a third, what do we get? And exponents. 2 plus half plus a third. First of all, I can divide number 2 as 2 over 1. Plus 1 over 2 plus 1 over 3. Next, find the least common denominator. For 1, 2, and 3, the least common denominator is 6. In order to make 1 to be 6, I multiply top and bottom by 6. In order to make 2 to be 6, I multiply top and bottom by 3. In order to make 3 to be 6, I multiply top and bottom by 2. So after we multiply, we get 12 over 6 plus 3 over 6 plus 2 over 6. 12 plus 3 plus 2, that's 17 over 6. So after we multiply, we get 17 over 6. When we multiply numbers with the same base, and exponent, keep the base the same, and exponent, 2 plus half plus a third, I get 17 over 6. then to the power of 1 over 4. If we get x to the power of 17 over 6 to the power of 1 over 4, we multiply the exponents, multiply the inner and outer exponents. So we get 17 over 6 times 1 over 4. 17 over 6 times 1 over 4. When we multiply straight across, top to the top, bottom to the bottom. I get 17 over 24. So the final answer is x to the power of 17 over 24. That's the final answer to H.